Bing, bang, and bong. It looks like we have all systems go here. And it's all here. So, and once again, it's Tuesday, March 28th this time around, 2017. And once again, Guy and I are here, ready to begin today's Keshe Plasma Reactor group and see what unfolds as the night goes on. I had a bit of a rough ending in the last workshop, and I haven't spoken to the parties involved, parties involved, but hopefully things will be smoother this week, and we'll patch things up if necessary or whatever it takes. Certainly, I think a lot of people on the planet right now have been experiencing stressful times, let's say. Just lots of emotional stresses coming through and different issues than normal. But we're still here, and we're still pulling together, and still a pretty good planet to be on, I think, for evolving and existing. Could be worse. Could be on the moon. It's pretty desolate there. Especially if you don't have any moon neighbors. Alrighty, enough of me yakking away. Since Lee Coates has his video on, and since he's here, I think we should switch over to it and see what the heck's going on there, Lee.
Good day.
Holy cow, what do you got? Oops, I'm sorry, I've got just a second here. I gotta plug in my extra other plug there so we don't get a echo on live stream. I think it was okay with just my voice, but okay, go ahead. Wait, what have you done here now? Your MagRav unit, your pyramid's been weightlifting. There's big biceps on there now, it looks like.
It's not flying yet, though.
Well, yeah, well, build up the strength first, and then you get liftoff.
You want to pin the picture?
Oh, sorry, it was for me, but not for everybody else.
There we go.
Okay.
It always looks bigger when you put it on the main screen.
Yep.
Now, this is just my work in progress. My attempt to make a starship formation out of car magraphs. So didn't have anything else to show today, so I thought I'd show that. The idea was I was going to have a bigger ring in the bottom, but right now this ring and this ring are the same diameter if you go by the centers of the things, so I might move this one up a bit, and then so that'll have a bigger toroidal field there and a smaller toroidal field and the smallest toroidal field on top. These two on top, I may change those to the Plasma Frontiers got this core idea. I may build that and put that on top instead of these two magraphs, but anyway, work in progress. It's not wired yet.
Oh yeah, what's the Plasma Frontier?
It's another group of guys who build plasma stuff.
Okay.
Frazzle does a lot of the training over there. Watched a bunch of his videos.
And where does that hail from?
Good question. There's members. There's a member in Australia, a member in England, and I think members in the States.
Frontier, I bet it was started in Australia. Yeah, it sounds like it.
Yeah, could be. I'm not sure.
Up in the outback.
They got 7 or 8 really active members and a whole bunch of followers. I'm not really an active member there. I just follow at the moment. So, but they're builders. So they build stuff and experiment, and that's why I like following them. They got some crazy ideas like me. So.
Yeah, right on. Alrighty.
But anyway.
Any questions?
But I haven't done much.
Any questions from anybody on that device, or shall we move on to Lee's secret levitation power source in the back there?
What do you see in the back?
I'm just kidding.
I had to look over my shoulder. I thought maybe
Yeah,
something
well,
was
I had to
floating back
wait.
there.
I had to wait because you never know here because sometimes you pull 3 or 4 different things out of your back pocket there somehow and they just pop up and all of a sudden we're on to something else. So,
I thought maybe I had a success hiding behind me.
yeah. Well, you never know. They do have these drones that follow you around now. So I'm sure that once we get a maggrav levitating, that's probably the first thing it would do. It would be following you around like a little puppy. You'd have to train it. Stay in the corner, please. Or maybe it'd be good to follow you around and provide an environment. Okay.
Yes. So I've been working on a second hand maggrav or hand scanner this week because I sent the other one off to my mom and dad, so it's not done yet. And
oh yeah.
And then I got my computer back from the repair shop, and just before the meeting here, it crashed 4 times in a row. So looks like it's got to go back to the repair shop.
Wow,
that's not the fun.
Not so successful. Yeah.
Yeah. So.
Yeah.
Anyway, that's it for me.
All right, thank you, Lee. Back to myself then. Yeah, it's funny. I was doing laundry the other day and I noticed the brand new fancy washing machine that had replaced most of the other ones that was to the right of the one that I was using. It was blinking. It was saying error. Error. And this woman came over and I said, I think that one might be saying error. And she says, oh no, I think it's okay. And she goes away and it's still 15 minutes later, it's still error. So I told the woman that runs the place, I think there's a problem with this machine. And she looks at it and goes, oh. She pulls out the plug, puts the plug back in, and it resets everything. And away it goes. It starts up and she does a couple of resettings and away she goes. Well, I said to her, it's funny, you know, the old ones you never had to do that to. They either worked or they didn't work, and they worked quite reliably normally. And here's the new ones. You have to actually reboot them. They have a computer in them. They're all computerized. You have to reboot them to get them to work. And I'm thinking, wow, what a crazy world this is that we even started with this concept of computers that you have to reboot and literally unplug and plug back in. It's especially on the Macintosh computers. If anything ever had a hint of not working right now, you just unplug it, wait 10 seconds, plug it back in, boom, everything comes back and works perfectly. Works virtually every time. On the Windows computer, you can't always get away with that because sometimes things weren't saved and files would get corrupted and so on and so forth. But it's interesting that I was thinking, what if we had automobiles like that you had to actually stop, turn your car off, and turn it back on again, or turn it off on the highway and turn it back on again. You know, we would drive along. Oh, I gotta reboot. Everybody, hang on. We lose the steering, we lose the brakes, and everything else during the reboot process. But hey, that's the way we've always done it. You know, but it causes crashes all the time. But it's jobs. That's where the jobs are. You know, this is
we hope it's going to be a little safer.
This is a human logic. It creates jobs. That's a good thing. It helps with the GDP, the all-important GDP. What's the GDP?
The gross, gross.
Probably more likely the goddamn something or another. No. Yeah, it's gross domestic product or something like that. Gross is the key word there. Anyway, let's Okay.
There was a joke. There was a joke going around the internet years and years and years ago. I remember. I just looked it up. What if Microsoft built cars? And the first one is for no reason whatsoever, your car would crash twice a day. Every time
Exactly.
they painted, every time they painted the lines on the road, you would have to buy a new car. Occasionally, executing a maneuver such as a left turn would cause your car to shut down and refuse to restart, in which case you would have to reinstall the engine.
Yeah, that's a yeah.
Macintosh would make a car that was powered by the sun, was reliable 5 times as fast and twice as easy to drive, but would only run on 5% of the roads.
Yes. That's right.
New seats would force everyone to have the same size butt. And occasionally, for no reason whatsoever, your car would lock you out and refuse to let you in until you simultaneously lifted the door handle, turned the key, and grabbed hold of the radio antenna.
Provided you remembered your password. You could
Yes.
say it backwards 10
Yeah.
times rapidly.
GM would require all car buyers to also purchase a deluxe set of Rand McNally road maps, now a GM subsidiary, even though they neither need them nor want them. Attempting to delete this option would immediately cause the car's performance to diminish by 50% or more. Moreover, GM would become a target for investigation by the Justice Department. And every time GM introduced a new model, car buyers would have to learn how to drive all over again because none of the controls would operate in the same way as the old car. And the last one, you'd have to press start to shut off the engine.
Well, yeah, some of those are almost true. The thing of I was hearing an ad for a car dealer. It was a domestic one of the domestic ones. I forget which one it was now. But it was all excited about this one girl talking to the other woman talking to the other woman, and about this new car, how great it was. It's just totally electrified, and got everything. It's connected to the internet, and it's connected here. It's totally connected. This is the key word, and in fact, the dealer was so good that they spent hours with me making sure that I was settled into my car and I was connected to my iPhone and connected to my tablet and connected to my home and connected to my lights and connected to my all these things. They spent hours with me. I think, whoa, this is what they're doing nowadays. It used to be, you spent a little time. They learn teaching someone this is the clutch and this is the brake and that's the gas, and don't get them mixed up because that's bad. But nowadays, there's literally a manual. I've seen some of the new manuals are literally, what's that? A few centimeters, approximately 5 centimeters thick. And you just go through pages and pages of options and preferences, and that's just for the radio. And then you get out the other owner's manual. It's literally it's you have to be a technician to figure out everything, or someone under 12 years old that's already brought up with all this, and this for them it's a snap. So for those of us in between, it's a challenge. But anyway,
Oh, man.
the point is that the dealer actually spends time with people to orientate themselves with, and that of course that's good for them, because what happens if they're suddenly their iPhone can't connect with their car? Well, they bring their car and iPhone and everything in, or they call up the dealer, establish that rapport with the dealer, and of course the dealer's happy to have them come back next time to buy a vehicle because they've been so helpful and so nice to them and all that kind of thing.
Oh yeah, man. When I get a car, I want the steering wheel and the brakes attached to the wheels. When I push on the brake, I want the wheels to stop turning, regardless of what state the car's in.
Yes, that would be handy. Yes, the new Google cars, for example, they don't have a steering wheel and they don't have a brake pedal either. And that would be a little scary, I think.
Yes, definitely.
And I was hearing about the new Tesla car. You walk up to it with your groceries and the doors automatically open for you and you get in and as soon as you do up your seat belt, the car starts up automatically, and away you go. There's no ignition key, there's no starter, there's not even a starter button, so far as I know. There might be a button, but you don't have to push it apparently. Anyway,
You must go with a little sensor into a key thing or something.
yeah, something like that. Eventually it'll just sense our DNA and give us the keys to the universe, and away we go. What part of Alpha Centauri would you like to be at in the next 10 minutes, sir? Well, I think we'll go to the western sector for lunch today.
Yeah, the blue screen of death takes on a whole new meaning.
Okay. Alright, so what else we got here? We got the comments from Jay here. Jay has a question that's confused him for a while about nano-coating wires. Just wondering if Thomas would draw a diagram to describe why wires turn black or get nano-coated. I'm wondering how the coating spreads. Is it to do with heat, or is it from a corrosion that travels like rust? I've never seen or heard a really good explanation on how it spreads and why. Just okay, so well, first of all, you say it travels like rust. Well, rust is actually basically a type of nano-coating. It's if you think of iron oxide, that would be what we traditionally call rust. And it spreads from the same basic process as the copper oxide, which is the black coating that you're talking about. It's a good question. Definitely. Thomas, are you there? Do you want to take on that, or shall I, or someone else? I'm not getting Thomas. I'll try to unmute you. I'm not sure if you're hearing me or you can talk. 1 second, he says. Okay. Okay, well,
nano-coating wires, for my magravs, and it's have energy flowing along the wire. The maggrav energy flows to the wire, and that maggrav energy is pulling the copper atoms off the surface of the wire and nano-coating the wire basically. And the interesting thing, you get like my 6-foot stranded copper wires on my car magravs, when I hook them, tie them together in the middle, the ones that aren't nano-coated to start with, they start nano-coating from both ends and work towards the center to turn black. And I think it has to do with wherever you have a wire connection, it's a flow blocker, equivalent to a resistor in electronics, and that sort of bottles up the plasma energy a bit, and that's why it goes black at the far end before it goes black in the middle of the wire. I always used to think it would start at one end and work its way to the other end, but that's not the case. So.
Well, if you look at what actually happens, I mean, maybe we could look at a whiteboard and do a little bit of drawing on that, and Thomas can help us along there too. But we can all contribute, perhaps. That might be a good way to do it. Let's try that.
Rick, somebody said it was because of carbon. The carbon just grows along the wire.
Who said that?
It was Jack Leonis. That was his understanding of it.
Well, where did that come from?
It's got nothing. There's no carbon there. It's copper atoms that are pulled off the surface, and then
Now,
they look black.
to be
Copper nanocoating.
to be clear, you can have. It is possible to have some carbon. It depends on, like, for example, if you were to do nanocoating inside the Coca-Cola bottle, as Mr. Keshe did, with ground up Coca-Cola bottle necks, plastic, and potassium hydroxide and sodium hydroxide, and a few other magic ingredients in there. Yes, there's some carbon that gets mixed in with the actual copper that's doing the nanocoating. But if you look at it, you see where's the get my annotation thingy up here, over there and there. I think that'll work. Can you see the whiteboard there now?
See it.
Okay.
Yep.
And let me see, this one, two. Just having trouble finding my annotate here. I got a pen, but I have no control over it. Okay, it must be here somewhere. Oh well, the heck with it. That's annoying. I know sometimes it pops up. Alright, well, I've got a little red pen of some sort here, I think. Okay, so let's, look at it like... Oh, I don't have a little red pen. It went away. I think I have to reshare. Let's try that. There's the little annotate thing. Much better. Okay, well, for example, Mr. Keshe often draws the surface of the copper wire. Let's say this is a copper wire here, roughly something like that. And he'll show the atoms or the spheres that represent the smallest parts of the copper. Now, of course, it would be way smaller than this in terms of actual atoms, but he represents them with spheres that are basically jammed in pretty good with each other. They're elbow to elbow, you might say. There's not much in the way of gaps or spaces in between them. Now, if you were still to look at them on a microscopic level, it would still be big gaps when you get way down in there. But still, relatively all the particles are jammed in together. So then we introduce something like the caustic environment. So it could be caustic, which is Na and OH. Or we introduce heat. Now there's other ways of doing nanocoating as well. You could introduce gases like acetylene or some other gas like that in a vacuum condition and with a bit of heat, and bingo, this could be nano-coated with carbon, because acetylene will be, was it C2H4 or C something, C2H4 or C, I think it's C2H4 or C4H8, H6, something. I think it's C2H4. Let's call it that. Well, it's got lots of carbon and it releases the hydrogen, so it can actually, under certain conditions, separate off into the carbon gas and nanocoat different objects. That's a different technique than what we use. We usually use heat. And sometimes with the heat or with the caustic method, there'll be some carbon involved with, for example, if this whole thing's in a plastic container, then it's going to have a carbon-based plastic that's, some of it's going to get torn off by the caustic, which causes it to break down into its components, and some of it might end up as part of the coating, which will start to form on this copper. But the copper itself is what creates its own coating. That's the whole thing. And what happens is these copper atoms, which are locked into place, shoulder to shoulder, arm in arm here, you might say, with the effect of the, you've got Na, which turns into a positive ion, and the OH, which is a very, very strong negative ion. And or in the case of heat, and you've got your oxygen that's normally O2, and it gets separated into its reactive oxygen and ends up, either way you get the, and you've also got the H2O if there's in that water environment. So again, you have oxygen and the hydrogens available to deal with. The thing is that the copper ends up becoming attached to the oxygen, and it builds up on the surface, and it builds up in a way that has much more elbow room between the atoms than it did on the base wire, the bare copper wire here, where they're all jammed up. So these get spread apart. This would be a combination of not just copper, but copper and oxygen. So it's actually a two-part particle, and possibly even more, depending on its process that it goes through, because even the scientists aren't completely clear on the process, the exact process that goes on the level of this nano coating, this copper oxide, the way it actually coats. And depending on the process, some of these processes can create, well, first of all, it won't be just one atomic layer. It'll then tend to immediately bring up another copper atom that will pile up on top of this one, and another one will pile up on top of this one, and it brings it up from down here. So essentially it creates a valley here and a mountain here, and you could end up creating, either with the heat method, it's quite easy to create nano needles. So you actually have a needle-like structure created from these copper oxide particles that build up here. So, and you could have a forest of these as nano needles, and they start growing by themselves under that condition, or under the condition of having a little bit of caustic there and so on. Or in the case of the hot caustic method, which is the common, generally recommended method with the Keshe Foundation and so on, then it generally wouldn't create so much of the needle-like structure. You might have more of a I think your microphone's open there. Maybe it doesn't have to be so much for this part till you Sorry, I just made a mistake there. So the idea is you got the same with the caustic. I should have done it differently. This is like the heat method over here. This forest. And the caustic method we're going to cross over and do over here too. Okay. So let's do with the caustic method, you could pretend it's more, let's say it would be more of a layering effect. So you'll have, as Mr. Keshe says, you could have 20 or 30,000 layers that build up on the surface of this wire. Okay, layer upon layer. And they could be built up. In the case of what Mr. Keshe does, it could take a month to build up the layers properly on a plate or a copper sphere that's being used in a reactor or something like that. So the idea is that with these layers or these wires or needles, whatever you like to call them, because with the idea is with different techniques you can have different coatings. So with the caustic technique it might be more like flakes, so it might end up looking kind of like flaky under a microscope, chunky sort of looking flakes. Or in the right conditions you could actually create tiny little pyramids on the surface of the wire. Copper oxide pyramids. Or you could have copper oxide cubes. Actually build up perfect little copper oxide cubes, sort of like tiny little sugar cubes, but on an atomic and molecular level, and keep building them up, even in layers as cubes. Or more likely, if you don't control the process, it'll be a mixture of flakes and pyramids and cubes and some needles, and all sort of could be mishmashed in and just look like a sort of a general black mass on the surface, even when it's magnified. So depending on the exact conditions that one does with these processes, you can have different exact conditions created from different geometric shapes, right from the most basic pyramid, which is the most basic three-dimensional geometric shape, to a cube, which is one of the next ones, a four-sided pyramid, up to different octahedrons and so on. Various all the geometric shapes can be created basically with copper or with gold as well. Other substances can also be trained to form certain shapes on your wire. So that's why it's important to be consistent. Although on the other hand, with the techniques that Mr. Keshe shows us, it's more of he talks about it having a broad spectrum, so that when it absorbs the little shorter waves, and it absorbs the longer waves and the intermediate ones and so on, because it's broad spectrum. Whereas if it was all these little pyramids, then it would absorb under certain frequencies primarily, but it might have another specialty that this mass doesn't. Like in the case of pyramids, it'll actually resonate and create a magnetic field above each of these pyramids, a little plasmon magnetic field, and that has special properties, diamagnetic properties and so on. Or in the case with the hot caustic, where you have multiple layers, 10, 20, 30,000 layers, then you have the opportunity for the possibility of plasma running in between these layers, essentially. So then you have a nice plasma running alongside your wire, and if you have on top of the top of the nano coating, and you've put a bunch of changing colors. Put a that one doesn't work either. Huh? Just pull that one. Maybe put a bunch of GANs on top of the nano coating, and that sort of opened things up even more and transforms these plasmatic fields and draws in the energy from the GANs into this plasmatic structure. If you get that going good enough, then it has a chance of actually activating the the electrons and the physicality stuff in the actual wire and getting some electricity out of it and so on. So each of these has their specialty. The nano wires, they have their specialty as well, and they're really good at being sensors. Makes sense. It's like fingers sticking out. In fact, I happen to make 5 fingers here. 2 of them are longer than the other ones. And I don't know, there must be a thumb here, I guess. But in any case, they make really good sensors because they feel out into the environment and they don't tend to break down so easily. So any gases that are out here can tend to activate these copper oxide sensors and feed into some electrical network that's attached to a gauge or something. Anyway, I've been talking too long without asking for questions. Jay, does that help at all? You got more questions about that?
Yeah, it looks good. I just wanted to add, I'm just trying to work out why nano coating appears black in color, and it's not, like copper. I thought copper oxide was like a greenish blue color. No?
Well, if you look up copper oxide in Wikipedia, let's do that right now, actually, because that's a good question. Let me see here.
Say there's like a church hall near me, and the roof's made of copper, but it's all green. So, like,
yes, that's because it's exposed to not just the oxygen in the atmosphere, but it's exposed to other sulfur and other things. There's lots of different oxides of. There we go.
Yeah, the reason the nano coating's black, though, is all the gaps between the wide spacing between the atoms or whatever. They absorb the light.
Right.
What color we see is reflected light, and the nano coating doesn't reflect any light. It all gets absorbed in all those gaps. So.
Right. Okay. So.
And it's not copper oxide. It's not copper oxide that's on the wire. It's not. It's nano copper. So it's not going to be blue or green or whatever.
Okay, well, let's look up here. Let me see. Let me just pull this properly. Here we go. For example, here's copper oxide. That's called the cuprous oxide, and it's red. You see, it's red cuprous oxide. That's it's got its own properties and so on. It's diamagnetic and superconducting and whatnot.
That's when you overheat copper that you come up with this, no?
Yes, you can. And then you can also have the copper cupric oxide, which is CuO. This is what we commonly talk about as the black coating on... whoops, what happened there? I should go back, I guess. Try that again. I'm trying to make the picture a little bigger and bring in the zoom. There. Now, this is from Wikipedia. So, back again, this is the copper oxide, the black stuff that forms on the copper wire normally. And it's CuO, that's its formula, as opposed to the cupric, which is the Cu2O, cuprous. That was cupric. Cuprous is the Cu2O. So let's go back. Let's try that again. Okay, back to this again. So, I mean, they made this for quite some time, but normally they get this by, you see it mentions it can be formed by heating copper in air at about 300 to 800 degrees Celsius. Now you asked, Jay, why is it black? Well, actually, if you look at the oxides of copper as it heats up, for example, I took a penny and put it on a red hot burner on a stove and heated it up. And you can watch the penny or any piece of copper. I did it with a copper plate as well. It'll turn the whole range of rainbow colors until it gets up to a certain temperature when it starts turning black or red. Those are the two main oxides. And it turns out that, especially in the heat process, that red oxide is actually the initial layer. So if we go back to the, let's just go back briefly to the whiteboard. And see,
Rick, do you mean underneath the black color then there would be like different layers of different colors? If you could see
well, no, I mean, like, as it's heating up, you'll see it.
yeah, I've noticed.
Like,
Like
you know,
rainbow, like oil.
it changes very quickly, like, boom, just blue and purple and red and yellow and all these different colors before it gets up closer to red hot. It won't, not red hot, but close to it. And then it starts changing to black, basically. So usually the way it goes, the black will be on these outer ones here. Actually, I should have made those in black to start with. So this whole layer will tend to be black, the one we see. But underneath that initial layer can actually be the red oxide. And what happens is that it starts out red, but almost immediately changes to the black oxide as it moves up this chain and forms the next layer, because these are rapidly forming these thousands of layers and so on. It can be, you know, it can be hundreds or even thousands of layers formed in minutes. So you know, by the time you see it's black on the wire, it's already got thousands of layers on it.
I got a question for you, Rick.
Mm-hmm.
Why do you think it's an oxide? You look at when I'm nano-coating stranded wire, the wire that has no insulation on it does not turn color. The wire which is protected from any kind of oxygen throughout the length of the wire turns black.
That's right. I've noticed that myself with.
I'm what I'm saying is it's not an oxide. It's a nano coating. It's
why
it's
would
a single
you?
copper atom that's pulled off the surface with a gap between it. It's not copper oxide on the.
Well, that's what copper oxide is. Copper oxide is.
No, I'm talking
CuO.
Yeah, I'm saying there's no O in there. It's just straight copper pulled off the surface, and it looks black because it's got the gaps between it. That would explain why, you know, a wire turns black underneath the, you know, the insulation. You know, it's.
Well, it turns black under the insulation because it likes that environment with a little bit of caustic. Then the OH separates from the sodium.
On my car magravs, I got no. You know, I start with a straight copper wire. There's no caustic involved, and the plasma energy turns it black.
You don't add any a dab of caustic to it to start it or anything to begin with?
The first
I thought you did that.
The first 60 magravs had no. It was just a straight wire off the spool. Now, right now, I'm making it. I'm nano coating the wire from tip to tip because I think that gets the energy faster to the battery. So I've changed my method for the last 40 or 50 ones that I've made.
Mm-hmm.
But,
Yeah, well, I mean, still, if you use a little bit of caustic, or a bit of heat, that's the process that happens. It's definitely a copper oxide. As far as I know, that's what
but
goes
when
on
I'm
there.
when I'm nano coating with plasma energy, I've got no heat, I got no caustic, but the wires are turning black.
Well, you still have a plasmatic environment, and if it's plasma, then everything is in its. See, copper, when it's in its single atom form, is generally in its ionic form, like a copper Cu plus or Cu plus plus ion, like if it's in water or if it's in the case of even moving on the surface, the way I understand it, it would be, in the case of the let me just share the desktop. That's probably the best way to do this.
My understanding is the definition of nano coating is a widely spaced atoms. It's a different state of existence, and it's just copper atoms widely spaced. It's not an oxide. I mean, when you use the heat, okay, I agree. You probably get some oxides in there. Caustics, I'm not so sure, and plasma energy definitely not. I don't think there's
What
any
about
oxides involved in that coating. So
Yeah, hi guys.
yep.
It's
How are you guys?
Hi, yeah, Thomas. You were originally asked for by Jay, so maybe maybe you could enter your 2 cents worth in here.
All right.
I'm pretty stuck on it being copper oxide, but I'm also was getting to the point where I wanted to discuss where there's actually, for example, if we look at the reactions that go on with copper oxide, where it goes into there's a lot of different salts and it reacts with different things, and some of these reactions that go on with copper are near instantaneous, so even the scientists haven't figured out the exact mechanism that's going on there to change over. Like, they say it's 2 copper plus oxygen yields 2 copper oxide for heating copper in air, for example. And that forms that black copper oxide, which should be, which they use for other things and that sort of thing. But that doesn't mean that it's so simple. It could be other complexes involved before it actually gets to that CuO point. And the copper oxides that we're talking about may not be just pure copper oxide either, because there's other things that get mixed in to that matrix. So it'll be what they call doped. It'll be doped with we mentioned carbon, or maybe anything else that's in the environment. That's the way I understand it. Anyway, I see your point there, Lee, but I'm not sure if we look up nano coating, that might help too. Okay, are you ready to? Let me just try that in. Not sure what Wikipedia thinks of nano coating.
But actually, guys, the
Does not exist.
oxidation, the stuff what we call oxidation, is actually correct, because oxidation gets few different stages. And on the first stage, that's the official oxidation, go to reds and so on. And we got the next stage of oxidation. Doesn't especially mean they do something with this typical way of absorbing oxidation normal. I mean the red color. The next stage, example for copper is probably 4 or something like that. The third or fourth stage of oxidation, and that's means completely different. I mean, for science, for definition, it's the same word, but in terms of behavior is something a little bit different. I mean, not a little bit, it's something different. I got somewhere photography on nano-coated copper, how they look. especially in
In a way, if you look at, for example, nanomaterials, not nano-coating, but nanomaterials, they are, well, the materials of which a single unit is sized in, between 1 and 1,000 nanometers, basically. Usually between 1 and 100 nanometers and so on. But they're not necessarily oxides. I think a lot of them are. I think actually most nanoparticles are, they're metals and semiconductors and so on, oxides basically. But not necessarily. You could have pure gold nanoparticles, which are not oxides, for example. But on the surface of copper, from the processes that are used, I think that we're talking about a oxidation type process, basically. So, anyway, go ahead. Go ahead, Thomas. Keep going there, and I'd like to hear what you want to say there. Just wanted to get that in.
And the one thing I show you, guys,
do you want to share? Sorry.
Yes, please. Yes, please.
Okay, I'll stop.
Be oxidation stages for copper. That's photo from atomic probably microscope. Let me show the screen. All right, I got it.
Is it? It's not a copyright picture, is it?
No, any copyright, something like that.
Okay.
Alright. That's the one. And that's the next one. That's the nano-coated copper wire. CuO, as you see, the hair structure. And on the bottom you get C2O. That's exactly what you say, Rick, before. And that's the, let's say, the red copper. That's the dark reddish copper or something like that.
That'd be the black. The copper oxide would still be black, even then.
That's the black on the bottom. Yeah.
No, it'd be the red on the bottom. Is the Cu2O is the red stuff.
Exactly.
Cuprous oxide.
Cuprous, and then cupric is the CuO.
So,
what's the source of the picture here? What?
The source is. Stop
I have a bit of an argument with that picture. I think that was for high temperature wires, and they grew them that way. Correct?
Exactly.
They grew it in a high temperature, 600 degrees Celsius furnace for 2 to 10 hours or something like that, depending. But it had a minimum time so that they could actually grow them. If you look at the pictures from that same experiment, that they only did it for a short period of time, they didn't grow wires at all. It was more like little flat flakes. So none of us have put the wires in a torch for, an hour straight trying to heat the coils or the plates or anything like that. So it's not like we're growing the hairs or the needles like that, which is a specific process where they put it in a contained environment and either use pure oxygen or a very decontaminated air supply, special lab air supply, and so on. But for us, it's usually very quick in terms of the fire process, and it won't have that same. It could have maybe little geometric shapes, or it might have flakes, or more of it could have little wires starting to grow. It all depends on the actual process, and it also depends a lot on the preparation of the surface of the material that you're actually using. The what do you call it? I highlighted here. How well it's polished, how smooth the actual copper is. If it's got a lot of irregularities, that's where the the actual copper oxide crystals will start to grow from the imperfections. But if it's really smooth, then you might have more multiple points where it comes from, and even little pyramids, even little hairs or whatever. Anyway, go ahead, Thomas. Do you want to draw something there? Or?
Actually, that would be perfect to draw something, kind of a quick explanation. I just need to organize some screen for myself.
This is a good topic because there's a lot of confusion about this, and actually what we need to do is do a nice little animation of the process, and that's something I'm working on, but it's taking some time.
The best.
Maybe we'll use this as the animation. Your drawing skills are probably better than mine. Try to make it an animation, and we'll see if we can work it in.
That would be a good idea. Do some animation with the stuff.
Yeah.
That's take time. And anyway, my way of doing nano coating, because that's gonna be probably the best explanation, because that's all my experience with the stuff. And when I got copper, that was actually Rick said a few minutes before with these different colors. Let's say this is my copper, and all right, that's a copper piece of copper. And normally when I heat with the, let's say, torch, flame, or whatever, in my case is a propane butane, if I could remember, the small torch, that's all. And you get the few different colors, and the different colors that's a different state of, let's say, oxidation, because oxidation is whether we like or not, what is the official probably name, the scientific name for the situation. And the first, let's say that's
let me interrupt just briefly, Thomas, about that, because I just remembered something I forgot to mention about the coloration, and it's got to do with Jay's question about why it's black. You know, black absorbs all the colors, so it doesn't reflect, and we see blackness. But the other colors that Thomas is showing here, this layering and all these different rainbow colors, are actually because of the particle size of that particular size of copper oxide in that particular temperature range happens to be bigger or smaller than the black particle size that comes in later, or the one before that. Or remember the bronze one that we're supposed to heat up the wires until the bronze color is shown, and then you quit there, and then when it cools it turns black from that bronze color that shows up. Well, that bronze is just simply another reflective layer of nano coating that is just the particle size reflects certain light wavelength frequencies, or light frequencies in certain wavelengths of light. So in other words, it's just a reflective factor. All right, go ahead. I just wanted to insert that in there because your drawing is so perfect.
all right. That's the different factors, exactly, because the secret is with this strange name, PN junction. This is the gap between the proton and neutron. The neutron is, as we know from Mr. Machran, the most important thing. Let's say this is the neutron. This is the proton. Here we get some sparks. Let's say that's the electrons. And PN junction, this is the gap, physical gap between proton and neutron. So the different interaction, what we do actually by gas state, the gas state actually create the plasma condition. The most funny thing, many of us get impression we do this process by straight heating, but actually heating is a combination with a few different fields, the plasma fields, and this combination of plasma fields creates interaction with a piece of copper. This is the pure plasma. That's the funny thing. We always mostly think, oh, this is something, you know, the fire, the something hot or something like that. But actually, this is just only two fields. The same situation when we try warm us hands, and you just need touch them, and they made this fast move between your hands, and you feel warm hands. Same story. This only fields between. So this is the PN junction. The different PN junction mean the different spectrum of light for us in a visible way. So the different spectrum, that's mean basically the different reflection, because something come here and go out. Let's draw like that. More prominent arrow. Like better option. All right. And the piece of light come here. Check what's inside. If it's enough space or enough interaction, they go back outside. So for some case we get the white color, for some other case we get yellow color, for some others case we get different colors. So that's the spectrum. Spectrum of reflexivity of light, something like that. So that's the PN junction, basically the gap between. When we do nano coating, that's what we do. We just drag the piece of copper from here and take them out a little bit, because we change the gravitation properties around the original structure, and this gravitation properties, magnetic gravitation properties, drag small particles, the nanoparticles out just a little bit. There's some on my drawing gonna be huge distance, but at reality is probably really short, tiny distance. They drag particles out, turn the particles, they change the properties, and the particles go back. It's like a magnet, like a small magnet separation with a few magnets. You get kind of magnets. Let's say put the plus to this side, and when you hit them, you just reverse all the situation, and your magnets is on the minus, but in the same position, but you get minus. So when you reverse all the small particles, you just create the nano layer, and between these small particles you get enormous space. This is the PN junction, exactly this small space. That's the secret why we didn't see any single light when we get really well nano-coated piece of copper, because there is 100% light absorption. Everything go down and never go out. So that's the secret behind. And if we got some different color on our slider, it's mostly piece of ganses, because I mean depends of way how you nano-coat your wire, because that's the most important thing. Okay, back to the start. When we got this rainbow colors, that's the different stage of oxidation. We probably see the moment when all the small particles travel across and they change structure, and that's the reason why we see the different colors. And on the end, we got this black, let's say, black copper. This is the normal copper, and reddish one or something like that, the shiny one. And the difference between the nano coating, I mean, Rick perfectly explained this difference. This is, I mean, if you look for the PN junction structure, you get basically the different structure inside. Okay, you get something like pyramid, you get something more like unregular shape or something like that. When you polarize the coils or this nano-coated copper, you actually create the structure with the one direction. You see nano-coated copper. Let's see. Oh. Let's see, that's the layers. Many layers. And when you polarize, you actually create direction for all the structure. When you don't do these things, the structure stay, I mean, some strange direction there. If I'm gonna point by arrows, you're gonna go every single way. Well, no any specific direction. That's the unpolarized. Unpolarized, that's the polarized. Polarized, always gets same direction. That's the main difference for us, I think, because when you do your maggraph, you need polarize your nano-coated copper. That's the first thing. That's the first thing when I do immediately after when I get the first black layer, because the first black layer means I got probably something like 30,000 layers here. Yeah, I think. But the most interesting thing happened on the bottom, and on the bottom, let's say this is my nano coat. That's the copper, and it's not only copper, because inside the pot, when you actually do this chemical way with caustic soda, you get different ingredients inside the pot. The different ingredients create a different environment. So the nano coating layer is not straight made by nano coated copper, by copper particles, like I draw here with the fire. I mean, with the fire, we still got probably some extra materials, but anyway, I don't know too much about this. But with this story, we know one thing for sure. If you get something like aluminum, if you get something like a piece of plastic bottle, whatever you got inside your pot, or inside your solution, inside your caustic soda, they always will manifest itself like layers inside your nanostructure, but like a first layers. So let's draw from the bottom. From the bottom, gonna be probably I don't know, maybe 10 layers of aluminum, because you got a piece of aluminum inside your reactor. So inside your solution, because solution basically in this situation is like a reactor for all these reactions. So the next thing gonna be even even some nano layers with earth, just space between, and that's gonna be maybe 5, maybe 6, or something like that. It's really, really, really tiny amount. And after then you're gonna probably get another layers. Depends what you got inside your pot. For example, with me is a different story, because I mean same story, but I got few extra ingredients. So I got in my pot I got extra piece of silver. So I got extra, sometimes not everywhere, but when I do maggraph, sometimes I got piece of titanium. So the next things when I got the next thing is piece of zinc. And so my structure looks a little bit different, because bottom of my nano-coated structure, I got same story, because I got piece of aluminum, and also I got probably some layers, some tiny layers. That's gonna be maybe 10, maybe 5 layers silver. Maybe next layers like maybe 3, maybe 4 maximum gonna be titanium, and gonna be maybe 10, maybe 15, or maybe a little bit more zinc layers. So I got combination of layers. If you're gonna look at closer, I need to clean up this one. So let's draw the layers. 1, 2, 3, 4. All right. This is my nano-coated copper. I mean, I'm not sure I'm okay with the right order for all the structure, because the order probably depends for neutron mass. I mean, how many neutrons gets every single materials. So the heavier,
It might also be in sort of an array on each layer, that it'll be like every 10th atom might be titanium or something, and then the next layer, every 10th atom could be titanium as well, and so on. This could be lots of different structures depending on your exact technique, and this is the whole thing that makes nano coating so amazing. I mean, if you've got, what do you got, maybe 20 layers that you've just shown here, if you multiply each layer being different times 20 is this goes astronomical just in this one example, and you multiply that all, there's so many possibilities, it's quite amazing.
Exactly, and by definition, we actually able. I didn't mention to do this yet. By definition, we get the most easy way to do every type of battery, because the only one thing what we need to achieve is a layer of different polarized materials. For example, I don't know, gonna be zinc or something like that, and the next layer is gonna be nano-coated copper, which is polarized in plus, so the opposite polarization. So, and we already got some piece of battery. So, but that's that's the reason why we got this electric currents on the piece of black copper. Sometimes after, when you change solution in your pot, you see when you polarize your coils, you see the different values, the bigger or the slower. This is the difference between the, I think, between the different types of nano coating what you actually got in every single situation. Because, for example, this is the nano coated copper, these layers. All right, and that's my, let's say, gonna be titanium, that's gonna be aluminum, zinc, gonna be oxygen, few layers of oxygen, all the stuff when I get inside my pot. So every single layers gets interaction with another one. So, but it's not the end of interaction. It's only oops. There's another interaction. So the next interaction is gonna be between the nano-coated and the titanium on the bottom. The next interaction is gonna be between the first, for example, let's say gonna be, I don't know, first 16 different layers, or maybe 14, gonna be different interaction. Then between the, let's say, gonna be maybe 30,000 nano-coated copper wire layers. And one, I don't know, let's say one type of interactions, the second type of interactions. So we get the third part of interactions between. So it's always many different ways to do. It's always always depends of us what we got inside the pot. I get quite a very specific concept from my nano coating when I do in a chemical way, because with the fire is very classic, and I think everyone know how to do it. I don't need any extra explanation. So let's draw my pot. This is my, let's say, chicken wire. This is very important part of the pot. This is my bottom, and let's say this is my coil inside my lovely pot. And on the bottom, I got piece of aluminum to start reaction, piece of Coca-Cola bottle, Coca-Cola bottle, and I got chicken wire or chicken mesh, depends of the country, because every single country is a different name for this metal wire. I mean, it's always same name, same wire, but always different animal name. In England, it's mostly chicken wire. In some countries, I suppose some different animals. Anyway, and this is mostly zinc and iron. So we got zinc and iron. So that's the very important part. I mean, if you guys watched a long time ago the short movie who actually Mr. Macron do about the nano coating, he dropped the the ion nail to the solution. That's the reason why we actually don't need drop always ion nail to our solution, because the chicken mesh, the chicken wire is already made with this component. So we already got the piece of ion inside the solution. So this is, let's say, level of my solution. I'll draw more precisely. This is my level, and of course I get caustic soda. This is the caustic soda. So everything happened here. We know what's happened here. It's fine. So if you like apply the extra materials like titanium, like silver, whatever you like, that's your place. And I get another part of my reactor. Another part of my reactor is because this is the, let's say, liquid condition. So that's the one part, and the second part of my reactor is a vapor condition. That's all the things what's happened top of the top of solution. So top of the chicken mesh, I get piece of aluminum. And sometimes I do this trick. Okay, I'm gonna draw from perspective, so it should be fine. And from the top, when I got my pot from the top, I formed something like a star formation with a piece of aluminum, like that. And on the middle, if I got possibility, of course, because sometimes I got terrible mess inside the pot because I got some irregular shapes and different type of capacitors, and it's not easy to do this. But always try to do this. This is my kind of fun with this situation, and I call this reactor inside. And on the middle, I try always apply the plastic bottle. So this is the aluminum, and this is the plastic bottle. I don't use the special, I don't use extra ingredients on the top sometimes, but really occasionally. Normally I only build something like a star formation on the bottom. You get star formation inside my pot with piece of plastic bottle on the middle, and I got same condition on the liquid and same condition in the vapor, because with the vapor all the stuff gets same components. I mean, this is the caustic soda, same things, but the gaps between the space are more bigger. I got different condition. Here I got smaller gaps. I got reactor inside. So that's one of the ideas. The new idea, really brand new. They got, I don't know, like not fully 2 weeks. This is my mate, the gentleman from Germany, but original from Poland. He developed an extraordinary way to do nano coating. He actually, normally with the solution, we use the water. This gentleman replaced, he's probably on chat now, David probably. Maybe I can see some chat. Sorry, guys. Oops. Okay. Normally, we get water, and this gentleman replaced the water to the alcohol. I was done few experiments, mostly with the I forgot the name, because it's a few different alcohols. The gentleman reckoned to me use the
isopropyl.
Yes, I was trying with isopropyl. Was fine, but you must be careful, because if you don't gonna blow up your kitchen, everything is, you know.
Same with other pure alcohols, yeah.
Exactly, and the next try when I done my last coils are made with the ethanol alcohol, which actually gives me fantastic results and looks amazing. But I was made this in a different way. I didn't replace all the single water to the alcohol. I just dropped something like, I don't know, maybe 100 millimeters alcohol through the big pot, something like that, just small amount to create different condition here. Because if I get alcohol get extra hydrogen bond. So that means we got more power from the nitrogen. And if we spoke about P and
We're going to need some color changes on some of your drawings here to once in a while for certain things, you know, you could just throw in a color. Also, well, no, it's good that way. I was going to say maybe the next thicker pen, but it's nice.
Yeah.
It's quite clear the way it is.
Right, let's do it this way, because this caustic soda is gray, is nasty, gray, and stinky. That's the one thing, and I always get problem with the caustic soda. And here we got different condition, and the blue color, I mean, kind of bluish color, is not accident, because if we got some piece of extra plastic, I was mentioning some different things. Not typical behavior when you do at cold, because I'm actually warm up everything. The pot is the steaming pot is closed completely, and I left them all the stuff inside the pot for hours, inside the vapor condition, in really hot condition. So if you get that many, let's say, hydrogen bonds inside, because I got hydrogen bond come from Coca-Cola, because that's the also CO2, because that's the component inside the carbon inside the bottle. So I got the piece of aluminium, which they give me reaction, and the colors here, the blue colors, is not accident, because if you're gonna start up, when you observe your coils after all this operation, the coils or every single I don't know, copper wire of all your nano coated stuff, they got very specific colors. This is like kind of ultraviolet. I mean, not is a violet, but it's not like an ultraviolet, but it's something like that. It's a very strange bluish color. The strange bluish color means something special, because that's the story with the absorption, the light absorption. When you get, let's say, light absorption, that means some part of frequency is turned back from this environment. Some part of energy is reflected. So this part of energy is actually that's what's it called? Oh man, I forgot now. Tritium. That's a specific bluish color. If you got, of course, this color. And same parallel when you observe the nature and you get the small bees, small flies, small animals around you, and you mentioned the wings, the color of the wings, you always get something like a rainbow effect, something with the kind of bluish rainbow effect. And this is the different gravitational field, because the color change, we don't know any miracles. This is not a magic. They change because the different environment for gravitational magnetic fields, and if you get different gravitation, you get different colors, basically, something like that. And that's the reason why the small bees, small I always call the animals, not the insect. The small animals always get the ability to fly, which is completely opposite to any type of flow of thermodynamic, aerodynamic, and stuff like that. I mean, many guys for these days, they look, answer why all the bees, all the strange, the small animals flying, and still they still don't know. When you get butterfly and you catch them and you're gonna disturb the dust on his flies, on his wings, you got actually completely destroy his ability to flying. This is the ganses, because if you get the, let's say, it's gonna be something like a butterfly. All right, the material on his wings, that's the pure GANs material, and the GANs do all the different gravitational fields around the small creature and the small creature flying without no any problems. So that's what we do here, actually, pretty much. But we don't do yet probably flying coils, but we actually do pretty much same situation. So that's my idea for a reactor, to actually invite more helium and create more heavy fields, because tritium is only field. It's not physical tritium inside. It's not radioactive substance inside the bottom. It's only fields. So, and the fields create conditions, and this condition is recorded inside this nano-coated layers. So this is my extra layers inside my coil, let's say, and somewhere there, I don't know where. I should probably sit down with some big atomic microscope and do some research, but I didn't get an option to do this now. But anyway, somewhere there is probably one layer with some tritium or something like that, because that's a specific color, or interactions between the layers, because they are a record itself in this condition. It's like a recording tape. Already generate something like an interaction, and this interaction is the tritium fields and stuff like that. So that's when I try to recreate many times when I do this hot bath for the coils. That's my way. But before, of many times, not with every single coil, not with every single capacitor with the battery, not with every single piece of copper, because sometimes I do only this method, this chemical method, with the caustic soda. But many times before I gonna drop to the caustic soda, I do fire. So I get this very specific nano-coated layer, really flat, really, it probably looks like I don't know, it's not especially like a forest, more like layers of soil inside the ground, something like that, with this pyramidal structures, probably. But I don't know, because I didn't check on the microscope how look my nano-coated copper after when I finish all these operations. But this is the fire, and after fire is the next step, because that's always first step, and after then is the second step. The second step is nano coating with caustic soda. So many times I do always these two options, and coils work fantastic. It's a little bit different thing than only fire or than only chemical methods. So that's my way of dealing with this nano coating.
Okay, let's see if anybody has any questions for you, Thomas. Thank you very much. That was
welcome.
It's great seeing your artwork and getting the explanation at the same time. I assume Jay, that you got most of your question answered from that, but you might have some things that still need to be clarified or whatever. How are you with that?
Yeah, Rick, that was great. So nobody could have put it better. So brilliant. So good understanding now. Thanks for that.
Yeah,
welcome.
Pretty in depth, and
well, I have a breaker here for a moment. This is Jenny.
Okay, and also I think I'm wondering if what Lee thinks about this, because he might still have a second opinion on it, and I might as well, if in terms of when it comes right down to the nanoparticles, what exactly do we have? Is it always an oxide, I guess would be the question there. But go ahead, Denny, I'd love to hear your
Well,
breaker.
I'm just asking a question about the mineral salts that people are using now. I know Mark did a mineral salt test where he put mineral salt. I don't know exactly how he did it. We haven't had a full explanation, but he used mineral salts when he's nano coating. And I see that that might be very good for the health coils.
I was done this a few times, many times. I was done with the one big health system, and that was the magnesium magnesium salt, which the different name is Epsom salt. But small drop, really small drop. I was use the different salts with magraphs. I was made 2 magraphs when I got also the magnesium salt, the Epsom salt, and 2 others types. Oh, just one normal salt and was a little bit sea salt. So just like 4 different average salts was everyone got probably at home.
Yes,
And
there's some tablets that they grind up that have these multiple mineral salts in it. I forget the name of it, but Mark, if you're here, you probably could tell us what you used. But I don't want to. That's all. That was just a
Mark,
question.
I'd love to hear from you if you're there, and I apologize if last week was rough and so on, and for anything in my end there. I hope everything's okay, and I entirely invite your opinion and whatever you have to offer here today.
Well, the magnesium is pretty important. So I think that's a great add to it because for the body, especially now with
Well,
a
Mark,
lot of
Mark did all that magnesium GANs for like a month for using magnesium sulfate as the instead of regular sea salt. I'm wondering maybe something has come out of that, especially the fuzzy thing that was growing. Something might have literally come out of that one. How you doing there, Mark?
Hi, Rick.
Hi, I can sort of barely hear you, but I guess it'll come through.
hi, Mark.
Hi, everybody.
It's
Hi,
getting
Denny.
louder. I think it's
how you doing, Mark?
the microphone will probably kick in.
Yep. No harm, no foul from last week.
No harm, no foul. Okay, that's the deal.
Good to hear that.
Let's go on. Carry on as usual.
So Mark, I had a question. Now, in your when you were doing the nano coating, you used the mineral salt in the nano coating as well. Is that correct?
Yes, I did, Denny.
And
Yeah.
first you used too much and it didn't turn black, and then you lowered the quantity because Armin mentioned that would be a better situation.
Yes, it turned my because I was making some some connection coils for my bigger unit, and a couple 3 weeks ago we learned that the bioplasma salts, the 12 salts, that's what it's called, is bioplasma salts.
Okay, do you remember the brand name?
Yes, it is. That's the brand name. It's called bioplasma salts.
Okay, thank you.
No problem. And I got it from a health food store, and I showed it a couple weeks ago, and I guess we all agreed that it's just the 12 salts. It's a cellular salt, and I tried to show the ingredients, and everybody, I guess, was in agreement, as well as Armin, that was the salt that we needed to start to use. I can show it. I have it.
Well, it was both in. Yeah, go ahead. If it's not intruding on everything, I didn't mean to breaker too big. I just wanted a small breaker. But you use it in your nano coating, and you also use it in your kit when you're making GANs. Is that right?
This was my next production run, and I don't want to, because I was a little bit out of line last week, and I don't want to step on anybody's toes. And if anybody's ready to go before me, go right ahead, because you know me, I got a lot of junk and stuff, and I could show plenty of stuff, but no, I'm started.
We're on a roll. Why don't you go for it there, Mark? I think it'll be fine. And unless if there's someone else that has to get in right now and has to leave in 10 minutes or whatever, then maybe they want to jump in.
I think Lee, when he shows his stuff,
Justin has his hand up. Justin,
Lee and everybody else, because you know me, but I'd be more. I feel funny always going before Lee. He always has a lot of good stuff.
Just before we continue, I see that Justin had his hand up. I hadn't noticed before, so I'm not sure if that was from before or something now, or is it a hand with an elbow that you want to get your elbows in here, or
just a little bit, if you don't mind. Good morning, everyone. Hi, Rick.
Okay, well, let's take a mini breaker off to this before we launch into Mark's remarks.
Just off of what Thomas was saying earlier with the nano coating process within the actual box, is it possible that we can continually change the layers if we change the environment, the additions inside the nano coating process? If we leave it in there for maybe a day or so and then switch the environment and do it again and repeat, and then we can stack the layers within the actual nano coating?
Absolutely. Yes. Some of the substances may permeate through the layers as well, depending on the size of the atoms and what you're putting in through the environment. If you put it into a vacuum environment, put a gas in there, you might have trapped some hydrogens in there. You could put in some radioactive stuff.
And one thing, Justin, if you like to try, do this in real environments. Try with the ethanol alcohol. Seriously, Justin, just especially when you do nano coating, the cold nano coating, when everything is it's not as steamy and hot. And alcohol help actually, how to explain in English, intensificate this process. Anyway, just a little bit ethanol alcohol.
A catalyst, or it's
exactly, just I don't know, maybe.
Well, they also with ethanol, they use ethylene as a gas often to nano coat something with carbon, because it's one of the simplest. What is ethylene? C3H6 or something, and so it's got carbon and hydrogen, and you can actually put a carbon coating. And I was going to mention that before you took off your multiple layer nice drawing there with all the straight layers, and at the top you could actually have a carbon, just a few atomic layers of carbon as a coating on top of all of the copper as well. It is possible to do that. And it would be done using something like that ethanol ethylene gas, which is related to the ethanol. Ethanol would be like the alcohol that's from the same ethyl molecule. So it's interesting that can be used. So back to your alcohol. Over.
Right, and then I had one more kind of question along that lines. Then, is it possible, if we're doing the nano coating kit and we have it closed off, say on the lid or maybe on the side, if we add vinyl tubes or straws or whatever, you know how they have the baby nose booger squeezers, suckers, or whatever we can use, that we can actually inject at different times, have those ready to go on the box.
Wait, have the what? The baby what?
Snot sucker. The baby snot sucker.
Snot sucker.
For the
what
nose.
the hell's that? That's something I'm glad I didn't find out about. What is it though?
Bulb syringes. They're called bulb syringes. They're just
Oh, okay, yeah. It's just
Both
like a
syringes.
turkey baster kind of thing, but smaller,
In
probably
reverse,
for
yeah,
kids.
smaller. Yeah, so if we had those ready to go with different liquids, gases, salts, can we presume that we have a certain window of how long before the nano coating actually reaches its peak? That
Yeah,
while
this is
in the
this is all.
forethought,
This I bet this question has been. How many thousands of alchemists have been dealing with this question for how many thousands of years? Like, no, don't put that in. No, put it in. No, put it in. And, it's, how many alchemists does it take to make a soup? It's almost it's probably true. Too many would spoil it because too many ideas. The thing is, if you had yourself with what if I put in this and this and this, and then Thomas against you, well, I use the silver and the titanium and the this and this. Well, right away, just each combination multiplies. When they don't just add up, they multiply, right? All the different combinations, and it goes exponential the more that's added. And then you add in another person. Guy does his this way.
The French says.
The French person says to do it this way. And I'm saying, I think you're all wrong. I think it should be this. All of a sudden, all the interactions are going astronomical as the possibilities and so on.
The direction I'm going with that actual question is a lot like Tetris, because when we have the nanomolecules and they all have specific geometric patterns, they can interlock and actually envelop into each other and create a perfect three-dimensional sphere. Not every one of the elements, though, actually does that all on its own. So the addition of something right now may leave a gap for the next one, as long as we find out exactly which ones lock in, just like the Tetris pieces. But we would need to know in order which direction to start, because if we did the one that totally blocks them off in the beginning, then we just ruined everything. But if we can start with the basis that leaves us those different gaps.
That's right. On the base layer of that brand new copper, before it starts to oxidize, because as soon as that layer is revealed, that base layer of the element, the physicality copper, immediately it starts to oxidize in there's any oxygen around, either in air, water, whatever, that kind of environment, especially the sodium hydroxide, and it will form a layer, immediately, and it'll start to just rip the copper off, but in a gaseous form of the copper, as it's in a plasmatic condition to be able to turn that copper atom and rip essentially you're ripping the electrons off and leaving the copper as a charged Cu plus or Cu plus plus, either one or two electrons being taken off. And that leaves it susceptible to that oxygen that's got a minus charge. It's powerful. And it happens to be there as the OH minus, and it's ready to just lock into that copper and mate up with it and release the hydrogen, which will instantly become attached to or become part of the water, or call it plasma water condition, and so on. So yeah, a lot of action happening there on that level of the right at that base level.
And one thing depends the way how you do all this process, especially in a chemical way. You produce gases non-stop, because whatever you're gonna do, you're always gonna do some gas. Even when you got this chicken wire, you got CH3 on bottom on your pots.
Yes, if it wears through the galvanized zinc coating, you could definitely get start to work with the iron. Even the fields have come through could come through anyways. Well, that's it. It depends on the exact environment. As as was mentioned by Justin there, you know, it is, it's such a, that's why this field, the field of nano coating, is so important. This all in the. Oops, it says my internet connection is unstable. Hopefully it's okay now.
So real quick, then the last part of the question then has anyone gone the direction to finding out the layering that would be best beneficial to do in what order?
You know what?
Well, wait a minute.
Good question.
Best beneficial for what? You have to
that's
specify.
what I'm getting at.
Exactly what you want to do.
Completely fill up the entire nano coating layers. If we have the 40,000 layers, to completely solidify them, maybe not solidify, maybe the wrong
Why
word,
would you want to do that when they're already perfect the way they are, in a way? It's the perfect. The copper oxide is perfect for transporting the plasma in between the layers. It's already set up to do that.
To build a potential difference in the actual electrons, negative versus positive.
Not electrons, no. The electrons, you don't want the electrons even to be in there, basically. It's the plasma flow.
It might be the wrong word. It might be the wrong word. But if to stick to a solid state without having to worry about anything else, right at the moment, say just a capacitor, a plasma capacitor, to do the inner core of the capacitor all in one area where it would be potentially positive, potential difference directed towards all positive. And then the outer, say we do like in an Alex bead where we do the inner post, the GaNs, the aluminum, and then the outer coil on the outside, then that outer coil to be potentially different, all negative. I'm just wondering, has anyone gone that direction to make it so that without even
I got your point.
There's solar. I'm sorry?
I got your point.
Well, the gradient's the whole idea there, right? Between the inner and outer.
Exactly.
It's a very easy thing to do. I do this thing sometimes because this is very handy when you do all these health units. It's extremely handy because with the health units, I mean that's my way how I do this. I deal with mostly zinc oxide. So because
Thomas, because
no,
okay,
not necessary. This is only
quick explanation. All right.
Yeah, and if I need some extra zinc because that's the field what I'm looking for. That's the right gradient between the CO2 and the zinc and the copper and stuff like that inside this medical systems, this health systems. So good solution when you got core for your, for example, capacitor or something like that. Just you need to put through the pots. Okay, I will draw something. I'll be quicker way.
Gotcha, see.
You reeled him in, right?
A picture's worth 1,000 words, and it's less. It takes less energy to run your finger than your tongue, probably.
Yeah, that's true. Okay, let's say I got piece of core. That's the core for example, for capacitor, and I would like to nano coat them with this very specific way. So the very specific way in my case does mean I need zinc oxide here. Okay, I got some ganses. I'm gonna use some ganses also too, but the ganses got dry condition. I need something with different condition. I mean, with the wet condition, the different fields, because that's gonna be a little bit different. Same guns, but the fields sometimes is a difference. It's bigger or sometimes smaller, but it's the same field. So if you're gonna do
excuse me, Thomas, could I get you to select the next larger size of pen width, line width on your pen? Do you know how to do that on the annotation there? It's in the colored square box, and you can scroll down and select it.
All right. Okay.
And it will show up a little bit better on the big screen.
Good.
It's not on the pen part, it's on the little square box of color on the annotate.
I see the colors. I see.
And then the drop down has a choice of line width.
All right, I got it. Yes.
Oh, that's better. Oh yeah, cool, really good. Yeah, thank you.
Wow, perfect. Wow, thank you, because I didn't know it. I got this kind of extra tools here. Wow.
Yeah, it's on the same color spectrum there, yeah.
All right, and I need some zinc here. Good story short. So I get some guns. I'm gonna mix it all the stuff together, but to make it faster and bigger field with zinc and faster interaction between CO2 and stuff like that. So I need one thing. The one thing is a piece of zinc shed top of my chicken wire inside my pot. Okay, so this is my chicken wire, something like that, and this is my piece of zinc plate. Normal and non-coated, just piece of zinc. And if you like, create this extra layer when you got your copper. Next one gonna be, for example, all this additional extra like aluminum and stuff like that, the basic stuff. And between, somewhere between, you will get something like maybe like in a gun state, or maybe like a zinc state. But it actually doesn't matter, because the most important, the layers will actually include the zinc, because we always call it the zinc, but this is the field, the zinc field, and we only convert the matter to the fields. So somewhere inside my layers, I got zinc field, and I actually, well done, because the first part of my job is done. Of course, after all this operation, the zinc plate gonna be completely disturbed. If it's really thick, if it's really thin, they're gonna evaporate. If it's thick, they will rust. So that's only one thing. We're gonna lose something. We're gonna actually transfer piece of zinc, the fields, through the copper. This is kind of the most simple way to transfer the fields from one place to another. I was done this thing with the copper Mac, because I was the side, okay, on the bottom, when I get normal Mac, the black Mac, right, this famous Mac of Life, and I was decided to do something extra on the bottom. So the extra on the bottom was zinc oxide, because physically, I'm basically everyone. I'm unable hold the ganses on the bottom, because how I gonna do it? I'm gonna stick them, glue them with the, I don't know, sticky tape. How I gonna do it? It's physically impossible. So instead of using ganses, the option was using the field from zinc. Same way. So when I actually do the nano coating for the for pot, let's see, that's my pot in 3D. This is inside. This is the bottom. I'm just reverse way. Okay.
Thomas, I kind of forgot about. We kind of got a bit of far astray here, because Mark was going to give his presentation here, so we should get back to him. Actually, he was supposed to be after Justin, I think there.
All right.
Okay. So anyway, nice pictures. Keep going.
All right, and because I would like to apply the zinc on the bottom and create something like, I know, the cup who always got conditioned CO2 and zinc oxide inside by fields. So the solution was turn the put them on other direction inside the jar. So that's the top. That was the bottom. And on the bottom, I was put something like a small piece of zinc, just normal piece of zinc on the top. And I left them for 24 hours or probably maybe 3 days in nano-coating process. So on the end, the piece of zinc completely disappeared from here. I got plenty of zinc guns inside the pods, but that was fantastic. And also the nano-coated layer here got a different color. It was a little bit kind of silver, especially on the inside, because the funny thing, all the fields travel across the bottom and actually create the extra silver layer, something like a silver layer inside the mark. So that was my experience with this transfer with the zinc oxide and the different nano layers inside the copper. Okay.
Okay, thank you very much, Thomas. Now let's get back to what Mark had in mind there, if you don't mind, Mark. You still there?
Oh, I'm here. I'm here.
All right, do you want to share your video there? Okay.
There you go. Oh.
I gotta do it twice. There we go. All right. Yep, we see your GANs arrangement there. Yep.
So I don't know. You know me. I don't know. This is probably what my fifth GANs production run.
Which you do for like a month at a time or something.
I try to do a 30-day run, right? Let me
Yeah.
just turn my thing here around here, but so that everybody can know what I'm doing, because I just try to show everybody what I'm doing.
Yeah, it's good to refresh people and not assume that they've already followed our series week by week here.
Yeah, so what I try to do is I try to make our three basic GANSs, CuO, CH3, and CO2 in different, in the basic forms, but, you know, in the beginning, my first GANS runs was, you know, with our basic salts and our basic coppers and zincs and our nano coating and our irons. And then as we go through time, I try to, as we learn, we try to do different experiments. So my last, just to try to refresh, I use a lot of Himalayan salt. It seems to be a very accessible salt, and it has a lot of different minerals and properties. I don't have access to the sea salts because, I mean, I guess I could get them from the where they do aquariums. I never use that type of salt, but I guess that's good salt. But I just haven't ventured there yet. More money. These are cheaper salts, and I just try to use what I can at a very low budget, just so that it could be accessible for everybody across the planet. So anyway, so this run, last month, my last production run was with, to answer Denny's question, was with Epsom salt, magnesium sulfate with, I always like to put a little kicker or something different. And the last one was magnesium sulfate with potassium glutamate. But I wanted the potassium in there because, and the only form that I could get was from the health food store, and they put this glutamate in there as a binding agent so that it binds to the potassium. So, you know, it's cheap and easy to readily available, and I don't use Amazon, so this is it. This is what I got. So it made a really nice GANS. It made a nice clear GANS. I still haven't determined. No, we haven't really determined what it was yet. it made no material on the bottom of it. It just made color. You know, like the copper made the blue color. The iron made iron made a real dark red solution, and the zinc made a clear solution. So, and there's really no extract at the bottom where you could wash it per se. So I just took it out of the container, put it in the gallon containers, and I've been using it, and I'm using it in different aspects of my experiments, and it seems to produce different results. As far as like I'm doing an experiment down below here where I wanted to try to create salt crystals on a Magrav unit that I had, and with this solution here, because of the magnesium, it seems to grow crystals faster than regular salt. So what I've been doing is I've been growing, you know, I open up the container and you see the white stuff growing, and then I close, you know, I call it burping the container just to get air into it, to, you know, because after a while the CO2 or the oxygen is eaten up in the container, and if you open it up, it's like burping a jar when to put more oxygen into the container. So that's just my thought about it. So that's that part here, and that's what I'm doing down there. This all here, to explain this Gantz run that I'm doing here. This run here will be, I started it today, and you can just by looking at it, how much material has already started to produce in the bottom. I've never used electricity. This is my first shot at making a Gantz with a small amount of electricity. Armin, you can't pick it up on the camera, but there's no amperage. It's 0.20. It's like very little millivolts. Just I mean, like a regular little AAA battery is 1.5 volts. So you could imagine this would say 1.50 if I had a battery connected to it. Is that correct, Rick?
Is that strictly a voltmeter? Is that the volts that you're reading on there, or the amperage?
Strictly volts. No amps are coming through at all. It's zero all the way across on the amps, and just voltage on top with a straight volt going through the wires. It
So is it it says 0.20?
Yes.
And is it on the 1 volt scale, or what? Is there a scale on the setting there?
Well, I don't know if there's you can adjust the scale by turning the dials as far as adding more voltage to it. You know what I'm saying? So
okay, that's for the output.
Creates a battery situation where, you know, like it's, if I wanted to turn it up, I could turn it up to.
Is it on the minimum now, or?
Well, watch.
Can it go down lower?
Can you see the 20?
Yeah, I can just see it there now. Yeah. Actually, if the camera is a little bit higher, we could see it a bit better. I see it's up to 30 now, right?
Yes. So if I kept on going.
Can you take it down to 10?
Yep.
Well, it's probably a good range in 10 to 20 well, actually, it's 100 to 200 millivolts if it's 0.1 or 0.2 volts.
Yes.
So that's quite a bit, actually. So yeah, that's
you think that's quite a bit? So it would be
well, it's
zero?
it's not gonna light an LED. It's not going to light an LED or anything, but pardon me, sorry.
So 0.10 would be only like a tenth of a millivolt, right?
Well, 0.1, is it 0.1 volt? In other words, 0.10 volts.
Yes. It'd be
Okay, that's
0.10
volts. Okay, that would be equivalent to a tenth of a volt, which is the same as a 100 millivolts.
Which would, in retrospect, would be how much to a 1.5 volt battery?
That would be that's 1500 millivolts.
15 times weaker. No?
It's 15 times weaker. So it's very weak in comparison to a AAA 1.5 volt battery.
Right, but compared to putting a drain on instead of putting voltage in, then it's it's a difference on the other end of the scale, basically.
So do you think I'm putting voltage in?
Well, that's what that thing does, right? It's not just a meter that measures it, it's actually putting the voltage in. Is that correct?
Yes, it's a power supply. So it's putting voltage into the unit.
Yeah, so something will be going in rather than when you put an LED across or put a motor across, then you're putting resistance across that eats up the voltage, eats up the current, rather than, in this case, you're putting current into the experiment, you could say, instead of drawing it out.
Let's add this to the equation. So,
now, wait a minute. Is this on your, to be straight, is this on your, is it regular salt? Sorry, I didn't have it plugged in. It was probably echoing. Is this on your salt, or is this in the Epsom salt?
No, this is just now. I did this one a little different. I did this one with because these are 3 quart containers, and like I said before, 3 quart containers, and then the way it works out is 1 quart of salt to 2 quarts of distilled water, which would be the right ratio. We did
a quart of salt.
Well,
like pure salt to 2, like a whole container of salt to 2 of those containers of water?
Because the salt is, it's distilled salt that...
It's already mixed, you mean? It's
yes, it's
solution.
already mixed in distilled water, and I soaked my feet in it.
Okay.
So it's a broke down solution of salt. And I know exactly how much salt I put in a 2-gallon container and soaked my feet in hot water in order to dissolve it, so that some of my cells would be in it. Caroline told us way back in the day to present yourself in the very beginning. That salt is the very beginning. So I make my salt with hot water, and I dissolve the salt by putting my feet into the hot water solution.
Yeah. Okay.
Sounds absolutely crazy. I know.
Not really. No, it does make sense.
But
then you dilute it after that with some distilled water. Is that the idea?
Yes, it's 2 gallons of distilled water to
1 of the other. I see now. Okay. Hello? Did we cut out? Oh, we have a
internet problem?
Yeah, we're having a couple of glitches here. I guess Shaw Cable doesn't want me to continue, or somebody. I think we're still broadcasting we're still recording, but we're not broadcasting.
Looks like you're recording.
Ah, good. No, I'm having trouble with my broadcast. It's the internet connection. I'm losing the internet connection, so I'm not sure if you're able to hear me properly even.
Yeah,
I hear you.
Zoom.
Okay.
Yep, Zoom hears you.
Okay, the live stream was having some issues there. It's okay right now, so let's kick back in. Okay, where were we? Sorry about that.
So anyway, our first basic lessons a couple of years ago, I was just saying that Caroline told us to become one with our everything we do. So if you do it right from the very beginning, I always was, my basic thought was when you start making GANs, it starts with salt. So the very first thing we do is salts and nano coating. And when she told us that to become part of the, everything, you want to be, if you want this to work as interact with you, then you should try to get it to the basic, right down to the basics. So a year and a half or 2 years ago, we were taught this. So now I just make my salts by soaking my hot in a hot foot bath because I've always bathed my feet in Epsom salt because I work every day. I have heavy work boots on, and it's very soothing to pull all the toxins out of me.
It's the best stuff for pulling out toxins that you can possibly imagine. I'm totally convinced of that after many years of. If you have a splinter, it's the most excellent thing to pull it out, basically. Yeah.
It just seemed to make sense to me when she said it a long time ago, and I don't even. These to me are basic things that I don't even really. I don't. They're like almost second nature to me. I guess I have to reiterate them to people that didn't get to hear that back then, that if you want to be connected, that if you want yourself to be connected with these ganses and feel comfortable working around them, then I guess you start at the basic. And those that I don't know how much closer you can get to starting in the basics is by putting your feet into the salt. It might sound weird, but that's
well, not to me, because
connection.
let me briefly interrupt you with a short story about salt and my knee, which is pretty close to the feet that you mentioned, which is I got a little. I work with my body as a mechanic and so on. I got a little splinter of something in my knee from the shop floor, and it started to get infected, and I went to the hospital and so on, and they started threatening that I'd have to get in there and get in under intravenous antibiotic for a week before they would even operate or do anything with it. It just had a little bump on my knee. I just wanted them to go in and remove the splinter, and I'd be out of there. No, they wanted to. I started to sweat at that point and thought, I can't do that. I just can't be in here for a week with an IV stuck in my arm. Okay, I have to sign myself out, and I had to get special permission from the doctor to leave the hospital and so on. I went to back over to where I lived and could deal with it in that situation and the next day. And it turned out that my wife's chiropractor, who was also a naturopath, had the suggestion in the waiting room and told me within basically 30 seconds exactly what to do, which was to wrap up my knee with an Epsom salt poultice, basically some Epsom salts on a cotton pad, and you wet it a little bit and put the Epsom salts on and so on in a certain way. And then the secret is you wrap your whole knee in saran wrap. Okay, that keeps the moisture in and keeps the whole thing just together. And so I put the pad over my bump on my knee and put the saran wrap over the whole works. And within half a day, the pain had gone away. Within a day, the bump had gone down. Within 2 days, it was like I didn't even have that infection, and the whole. They were threatening that I would lose my leg in the hospital there. That's what they said would be the result of this. The blood poisoning was starting to spread and so on. And here it was, this simple Epsom salt was able to remove all of that potential suffering. And I found out later that's what they used in the First World War before they had antibiotics and penicillin and all this kind of thing. They used Epsom salts on the wounds. That's where the term salt a wound came from. was actually a good thing, and it didn't hurt. It was pulling out all the toxins and stuff. It'll pull splinters out. I found that out when I was a kid, and my father made me stick my thumb in a jar of hot water to remove a splinter. Hot water and Epsom salt, actually. So yeah, anyway, I thought I'd interject that little story. It's sort of relevant to your Epsom salt tale, but go ahead, Mark.
Well, Epsom salt has just been used forever and ever, and so just I used to use it bathing, and like I said, I have worked on my feet my whole life. I'm a painter, so you stand on your feet your whole life in heavy boots. What's going to hurt the most is your feet. So I used to come home and soak my feet in Epsom salt, and I felt a whole lot better by the end of the day, and I could go back the next day and go to work. So when Caroline said that it was a good idea, it only seemed natural to me to just do that, and it just kind of worked into my program. So whether it seems weird or not, that's how this is my process. So these are my 30-day runs on my Gantz. So, but the only thing different about this one is I use the Himalayan with my feet in it, but this one I use the 12 salts, the 12 bio salts is the kicker. So I had to understand, because I didn't know how to measure these little things from the health food store, and so Armin kind of helped me out to determine grams. You should put how many grams in, and then I thought, well, then I had to go to the internet to figure out liquid grams per quart, quarts to grams, and it's in a liquid form. So I didn't really, it's a formula that is really bizarre. But anyway, it works out to 950 grams of liquid to liquid, from liquid to liquid grams. I don't know what that means.
That's for a quart, you mean, right?
Yes, per quart.
And that would be a U.S. quart probably as well,
Yes.
not the so-called imperial quart. Yeah, that's why I'd like to deal with metric, because then if you got a liter, you have 1,000 milliliters of water, for example, at 1 gram per milliliter. So if it's 1 liter, you got 1,000 grams or 1 kilogram. So it's all so easy to figure out then. But this imperial system, boy, the U.S. is holding out for that. Canada was, and I still am, and people tell me centigrade temperatures, and I gotta try to convert back to Fahrenheit. That makes more sense to me, and so on.
Well, here in the U.S., we're, when we go to Google now, I come to find out when we search things, we're limited to certain things, and these are the parameters that we are given.
Well, it's quite strange. Yes, it's when you look at the rest of the world, almost everywhere now has changed to metric, but the U.S. is really holding out, and it turned out to be that was one of the big problems. I think that was even with the space shuttle, or one of the major accidents where they just between the computer files that were being switched back and forth, there were some in metric and some in English, and they didn't quite get they thought they were in millimeters and they were actually in inches or whatever. It was not adjusted properly.
It's a sad situation when humanity can't even talk to one another.
Yeah, you think we could agree on things like that by now, but we're getting there. We're getting there.
That's why the internet was invented, so that you can just click on
the converters,
gallons to liters, and back and forth, and that's why the Americans waited, so that they could invent the internet.
Thanks, Denny.
Hey guys, can I do a quick break in here?
Sure.
Okay.
Easy conversion that I figured out over the last week for 1 gallon of distilled water to 2 cups of salt to give you a 10% solution. That's the exact measurement to make it easy. And also, I meant to break in earlier, is that the thing that we have that's an X factor with nano coating, with creation of GANs and everything else, is our intention, which is also the same as our wish, has a major effect, especially plasmatically, on everything that we're doing. And I just wanted to share that real quick before I had to go.
Yeah, that's a really good point. Yeah, thank you very much.
And great to see everybody. I love you all and see you around.
Well, could we just ask one question? Two pure cups of salt to 1 gallon?
Yes. Two cups of salt to 1 gallon, since we're getting distilled water by the gallon anyway. Also, I wanted to throw out there an easy way to make a home distiller is take a Dutch kettle or a pressure cooker, take the pressure valve off, and adapt a 1/4-inch copper line, and then just make a coil in like a 5-gallon bucket, and then you have a inexpensive distiller. You could also do it with a tea kettle, and that's another way to save some money and make your own distilled water and grain alcohol if you tend to go that way. But that's one way to do it. Just be safe.
And what I've found the easiest way to get your salts, different percentage of salt solution, is just mix what I do is I got a 5-gallon bucket. I throw some water softener salt in it, which is on the bag says it's 99.9% salt, and I fill the bucket full 3/4 with water. I get 100% salt solution. Then I just take a syringe. If I want 7%, I take out 50 milliliters or 70 millimeters, I mean, and then fill it up to a liter. In a liter, I use a liter measuring cup, and fill it up, and I got 7% salt solution. There's none of this measuring grams and all the rest of that bullshit. To just start with 100% salt solution and dilute it down to what you need. And so if you want 2%, you just pull off the 20 milliliters. And if you want 10%, you pull off 100 milliliters. It's super simple to get all your whatever percentage you want. If you start with 100% salt solution.
Right, so it's a percent of the 100% salt solution of what they call a saturated solution of the salt.
Exactly.
Right. It's that's interesting.
And the water softener salt, they mine it out of a salt mine, and so you got sea salt from a few thousand years ago. So it's you're using all that mined salt is sea salt basically. So.
Yeah, and it could be more pure than the salt from the oceans of today.
Well, who knows? But it doesn't really matter. The thing is, the reason we don't know what's in the sea salt, and then if there's 0.1% of something else in this water softener salt, so what? And I don't see the reason for using distilled water. I mean, we're using sea salt. It's all got all kinds of minerals in it. So why not just use tap water with some more minerals?
Well, one of the minerals is chlorine that's often added to the tap water in cities, and that can definitely be something you don't want added to. Well, I mean, on the other hand, is sodium chloride.
Yeah, so it doesn't matter.
I think it's a different form of chlorine is the problem there. It changes differently. But
we don't have fluorine in our water. No, fluorine is bad, really bad stuff. But anyway. So anyway, that's just my 2 cents on that.
Yeah, I guess it depends on what exactly you're doing and what what exactitude of environment and that kind of thing. Maybe for example, for energy maggrav, it's okay to do it a certain way, but if it's for a flight unit that goes to space, maybe it has to have more exactitude for those conditions so that you don't end up just to the left of Alpha Centauri instead of on Alpha Centauri and spend the next 100 lifetimes trying to get that last degree back.
Yeah, if you're trying to make CO2 for eye droplets or something, well, then you might want to do something different.
Yeah, exactly. That's a great example. Actually, you'd want something as pure as possible, and in that case,
Exactly.
anything that you ingest, really. I mean, you put it on coils. That's one thing. You might get, some really cool results. Maybe you'd actually activate that genie in the bottle from your particular concoction of ancient, elements that were used in alchemy or something. And hey, it's entirely possible. I've got a theory on that. Rubbing the nanoparticle surface of the genie's bottle with the insulator and nanoparticle conductors and so on inside, and bingo, you're making plasma. Once that comes out of the bottle, it's hard to put back in. Anyway, okay, let's get back to Mark here and see what do you got going here, Mark? You got it looks like a plasma capacitor and
Yep.
hooked
Plasma
up.
capacitor.
Okay. Right, so it's hooked up to the outside coil and the inner coil or inner wire, it looks like.
Yep. Outside, inside.
Okay, now what scale are you on there?
I'm on the 200 millivolt scale.
200 millivolt scale. So we have roughly 3 millivolts coming through.
Yes.
Okay.
So, last week, this was what I was going to, I just have some questions because I don't know how to really read. These are just prototypes. I just was fooling around with these capacitors. I have, I have a version of it here, a raw version that I can explain what I did. But the question I have is so that you see this now, I made 2 of them just for a prototype, and so it has GANs and it has some other things in it, but do we have people in our group right now that have standalone energy that's going just from the outside to the inside with nothing else that we see of, that we can measure anything?
Well, yeah, there's that would be like the difference between a plasma capacitor and what they call a plasma capacitor battery or plasma battery, and
Right.
that there'll be a more or less constant current or constant voltage that comes out, and current actually too, and there's something between the electrodes. But it may or may not stay that way for months. It depends on the substance in between the coils, the electrolyte it's called, or whatever is used in between there, and the construction, whether it's got dissimilar metals, like if you've got copper and aluminum, for example, then there'll be a voltage just between the copper and aluminum until the oxides form, and then the voltage drops off, and then it's not able to conduct in between anymore, and so on. That's why they use certain electrolytes in between those plates in order to keep it from oxidizing and messing up the circuit. So if it continues to put out, and if you're able to draw something off of it, like for example, if you had, I don't know, maybe 100 of these in a row, then you'd have 300 millivolts. Still okay, so you had 1,000 of them in a row, you'd have 3 volts. Right. And then you'd have enough to run some LEDs, for example. And if you could run it continuous, like you say 1,000, people may laugh, but hey, Elon Musk uses, was it 6,580 or something laptop batteries to power his cars, just because the patent on the lithium larger batteries were hogged by some of the larger oil companies, and so he was forced to use these tiny little batteries, but multiples of them, in order to make up his very, very powerful thousand kilowatt battery packs, you know, or not
But-
1,000 kilowatt, but capable of putting out 1,000 horsepower into the motor.
Can I ask you this, Rick?
Mm-hmm.
In a battery situation, material that's in the battery is constantly being broke down to where it's no good anymore, right? Is that
Well,
how?
essentially, yeah, or to a point where it needs to be recharged, where it puts the particles back on the plates or puts it back into the solution the way it's the way it was originally when it had the charge.
So in these plasma capacitor batteries, which we're trying to create, we are because I have insulation in between each one of them. There's no touching of each of the metals.
What'd you use for insulation? Like paper? What do you call it?
Oh no, paper. I didn't think paper was good enough to insulate.
Okay, what'd you use for insulation between them?
Well, in my prototype here, or
Used the plastic pipe. I think that's what you showed, or
so.
plastic pipe, right? Is that what I see there?
Hold on one second.
Plastic tubing.
Yes, I have some of that in there. So in my very beginning, I have a copper, 14 gauge copper wire.
Mm-hmm.
And then wrapped around the copper wire, I have a thin wire of brass.
Oh yes, right. Okay.
And then the brass is inserted into nickel. This is pure nickel.
Mm-hmm.
Okay, so the three metals together are in all touching.
Right,
And
they'll act all as one conductor basically, because they're not
Yeah.
super nano coated and so on at this point. Let's say.
Well, I did nano coat all these. So, but the
Okay.
insulating factor is
Mhm.
this plastic tube, and
Right.
I nano coated that. So, so once
so,
that
so the other wires that you nano coated, do they still conduct electricity? Like, will the inner one conduct to the outer one if you hook up your meter and put it on the beeper on the meter or the ohms or something like that? In other words, if they're really super nano coated, it'll be infinite resistance, and it'll not conduct between each of those three metal layers, that metal wire parts between
So
the
if
copper wire and the two other tubes around it, basically. So, but you know, it's no big deal. Let's say they do or do not conduct. You still have it insulated by this big chunk of plastic tubing, right? That's the main point here.
well, there's a big chunk of plastic here,
Yeah.
okay, and then there's an aluminum wire that
Mhm.
I coiled aluminum,
Right.
and then there's another big chunk of plastic here,
Right.
and then there's a zinc plate here,
Mm-hmm.
and then there's just a plastic filament here on the outside.
Right. So
And then
when
there's
you
copper.
and when you hooked up with your wires there, you're sure that center pin that the red connector is hooked onto, the red alligator clip, that one, yeah. That center pin's not making any direct electrical contact with anything else that goes to the outside coil. It wouldn't be touching on the
No.
other end or anything like that, right?
No,
Just
it's
it's
connected
separated.
and the funny thing is, because when I made this inner coil here, when I made this part here, when I inserted this whole I don't want to lose it. Ah, darn it. But anyway, when I inserted this whole thing, all this was nano coated, and then I rolled it in a GANS, a GANS solution that I make a paste or anything. But the funny thing is, when I made that paste around it, and then I made the paste, and then I rolled this whole pin in the paste, and I can show you how I made the paste. And then this was all paste, like first I took this off and I put the paste around here. And then I inserted this in. God bless you.
Thank you, Mark.
And then I inserted this part into there. Now there was Gans paste on here, and then I Gans pasted this part, and then I inserted it into the tube. Okay.
Mm-hmm.
So now this part here was all. Let me, if I can just get it out. If you can just imagine, I slid this all in with Gans. Well, I can't get it now because, oh, there it goes. So this is all, and then I hot glued this end so that nothing could come out.
Okay.
That's where the
That's important. Yeah.
Yeah. So nothing comes out of that tube. So now the second one, I did the exact same thing. This one's a little bit harder to do, but this is aluminum in a plastic tube, and it in this one is sealed the same way. So each time I did it so that none of the Gans would come out, I put the Gans on the tubing and then, or on the material, and slid it in the tubing. So that's how because I wanted the Gans on the material, not on the tubing. So
right.
The Gans would be on the material here, and the material on the zinc plate.
Mm-hmm.
And
Nice.
they're all covered and never touching, because I sealed each bottom, and I can show you that in a minute. So
okay, well that's great. Thank you for explaining that. So we could establish pretty much there's no direct electrical conductivity between the center pin and the outer coil, let's say.
Yes.
So it's either some sort of resonance or inductive, or is picking up fields, or something other than probably something other than like a battery type situation, right? Like in a battery, the plates and the electrolyte have to be connected somehow. Yes. And this isn't really connected. I mean, it is connected technically with the air. There is the air as a connector, but there's
no air because
yeah, I know, sealed on the inside there, yeah, but I mean, you've got a little bit of air that would be touching on the top of that connector.
Up here.
Yeah, it's actually, an air connection there, and then between the coil, there's a lot of air as surface area on the coil. I mean, that's how plasma balls work, for example. They only have one wire that goes to the actual plasma ball. And I kept thinking, how does it work if it's only got one wire? That doesn't make sense. But the return circuit is the globe itself and the air, which goes back to the circuitry in the base of the plasma ball in that case, to complete the circuit. So you actually have a complete circuit from one end to the other. But in this case, there's no real complete circuit that we could say. The air couldn't, is too weak of a possibility. But it could be something to do with fields, because you have a nice electromagnetic coil there. It's a perfect, if it was tuned just right, which it may be for certain things. And it may be picking up on, for example, if you move something into close to that coil that has power in it, like a light bulb, or maybe something turned on, a motor, or some other electrical thing.
How about a transistor radio?
Maybe it might pick up on that. See if it increases the voltage, is what I'm thinking. But
it already did.
I was thinking something more like, plugged into the grid or something with a transformer would be good, of some sort of chunky transformer.
Sorry, I don't have a transformer.
Well, like one of those plug-in.
Look at it's going up just with the radio.
Try touching the antenna of the radio and see what happens. Just touch the leave the radio there, but just touch the antenna with your hand. No, I was thinking with your hand, actually. Yeah, have the
You
radio
ground it with
close.
your hand, yeah.
And then touch the radio antenna with your hand and see if you can change the...
No.
Well, it went to 3.9, now it's 3.7. Well, no, it went back to 9, it's jumping around. Oh, it went to 40 briefly. Yeah. See, now it's up to 40, 41, 42. See, you're absorbing fields, and probably if you... and I'll let go and see if it goes back down. Might take a little bit. There it goes, 39. No, yes, no. Is it random or is it true? Oh, there it goes, starting to go back down again. Okay, let's try it again. Try grabbing the antenna again, see if it goes up again. Well, certainly not jumping up the way it seemed to before. It's back stuck on 37 here now.
Okay, well that was fun, but my real question here is, watch this. This is example A. You know this guy's over here, right?
Yeah.
And now it's on 200 milliamps and it's overloaded.
Right. Okay.
So I'm gonna go to 2.
Is that a 0.5 or 0.6? Is that the... I can't see.
It'll go up to 0.64 if we just let it build. It's more than a half a volt.
Well, we see quite often in the 0.3 to 0.5 range turns up for some of these things. But the thing is, by the time you try to put any kind of load across it, like by a load I mean an LED or some sort of motor or resistor or something, that it seems to knock the voltage right down to practically nothing. So it doesn't have much oomph behind it, is the ones I've seen. But on the other hand, I mean, if you had 0.6 volts and you had 3 of those should be enough to light an LED if it had any kind of amperage behind it, for example, or 3 or 4 of them.
So what I did was I made a little video of it, and so anyway, because I've been playing with this for a week now. This is the weaker of the two. This one is the weaker. So I put a couple of LEDs, one here, and then I put a crossover one. And what I came up with, and I didn't do the experiment because I didn't have it, but when I started to move the voltage meter, right now this will stay consistent at 624, 625, 623. It's stable. This has been stable since last week. It hasn't changed. So then
Curiosity, satisfy my curiosity, if you take the other one that's not hooked up and move it right beside the one that is hooked up now, does it change the voltage?
I did all that. It's glued.
Yeah, just, it's glued. I'm sorry, okay. Gotcha.
Down. Yeah. So let me do this because a lot of times I see these things and people say, oh, there's a magnet or something. So I glued it to a piece of plexiglass so that everybody knows I'm not fooling. I'm not, there's nothing on the bottom. There's no wires. It's standalone plasma. This little guy here is standalone, making a 0.5 volt of plasma energy. Everything inside it is nano-coated. Everything inside it is gansed. Everything inside it is everything we've been taught. And I'm getting a 0.5 volt of energy out of it. So the reason why I made these is so that I can put these on my GANS production, because we talked about if we could have a plasma energy feeding my production, my GANS production, which now I can, now I absolutely know. I'm up top here, I'm only using 10. Here I'm using 6.632. So could you imagine this little guy hooked up to one of my little containers and feeding energy into it?
Yeah, but that's what I was saying before. Once it's hooked up, you'll probably find that'll drop right down to maybe 0.0 something instead of what you see there. But it would be interesting to hook it up the way you have the other ones hooked up and see what actually comes up.
So
now,
then
go ahead.
I actually hooked the two of them up together so that there would be a pop.
My next question, or my next thing I wanted you to do, was hook them both up together. I would hook up like the one with the red terminal, the way it is there now, the red one. But the other one on the bottom, the other black alligator clip, could be put on the body of the other coil. Yeah, and the body of that one. And see if you put your hand in between them, whether it changes the voltage. You know what I'm saying? Yeah, okay. If you can hook that on there. Otherwise, you could even hook to the pin as well, but I thought the coil would be more interesting. So we're not seeing anything there right now, eh?
Well, it's going back from...
Try hooking it on the pin then instead of on the coil, and see what you get there. Yeah. That would be interesting. Still no voltage. It makes sense in a way, but now see if you connect it with
yeah,
your...
but it's, you know how it flashes? How come it flashes the positive to the negative?
Well, it's sometimes there's random voltages going on, and it's not really accurate enough to pick up whether it's exact or just random stuff in the environment. Try putting your hand in between it. Yeah. Does that change anything? Can't get any actual reading, eh?
No, but it makes that little plus minus sign go faster.
Like maybe if you touched each coil with your fingers or something, but I don't know if you want to touch them. That should make some sort of connection. Nothing, I can't see.
Grounded it out. No more flash.
Yeah, interesting. Okay, thank you.
See, if you're in between there, it'll give you a lot of flash. I don't know. So it's just an experiment, right?
Yeah. And so go ahead.
Well, the reason why I made them was if it is making a little bit of energy every time I put it back here, it's 6 something. So when I
yeah, it's very consistent, isn't it? Very consistent.
Very consistent. So the other day, before I glued these, because I knew I wanted to present them, but I had them in a figure 8 configuration to where I had hot to negative, positive, and I had it crossed over. And the thing that it came out was when I clicked it down to here in the ohms, it held 800 ohms consistently. Now, I don't know what 800 800 ohms mean? So I went
Well,
to the.
yeah, that's resistance. That would be, and it may be hard for the meter to measure it because of the back voltage going on. Normally, a resistance with a meter you'll measure with the resistance out of the circuit rather than the circuit providing a voltage. But if you're getting resistance, that's just indicating probably more or less just the resistance in the wire, in the coil. Actually, if you're getting any kind of high resistance, then that, or any kind of lower resistance than infinity, that means you have some sort of conducting path between that center wire and the outer coil. So that might mean there's some sort of it could have a salt coating on something. The salt is a conductor, and it would make things make the plastic into a conductor instead of an insulator, for example, or some other thing that gives a it should be in the infinite, should be in the megohm range of resistance between that outer. Even between the outer coil layers, you shouldn't be able to get any lower resistance than megohm. It should be up in at least in the hundreds of thousands of ohms, a high kiloohm or megohm range. So you said it was what, 200 ohms?
800.
800 ohms, right? That means it's not high resistance. That means it's still conducting, which means there's some circuitry going on between your outer and your inner parts there that are probably connected in some sort of conducting way. It may not mean that. It may mean that the meter's getting fooled and it's giving you a resistance reading because it's also trying to take the resistance at the same time as this 0.624 volts is going through, and it's going, what the hell is this guy doesn't know to take the resistor out of the circuit. Well, the meter doesn't know that you're the plasma experimenter, not the electron experimenter. So it has to get used to your techniques and so on. And the meter has to adapt to you, not you to the meter. This is the way of the future, It's
I think so. So these are just my prototypes. So anyway,
that's cool.
For my bigger unit, I'm working on some of these things. So I get a little bit more resonance in the inner core, and with this 12 gauge stranded wire, I'll know that because with a solid pin wire, the nano coating it's really hard to get nano coating in and through it. So with the stranded wire, and now I know that the insulation factor, I can nano coat the insulation, and then I go from there. And then I got a bigger 14 gauge wire, and then I use stranded. I don't know if you can see it, but I put stranded wire in between the coils so that I get a resonating.
Holy cow, that's a lot of details there. Yeah, right. You got the 12 gauge double barreled spiral wound double. Sounds like it'll work. Yep.
Well, I don't know if
it even kind of looks like a ray gun now with the all the spiraling and stuff sticking out. It's pretty cool, actually.
So I learned that I have to cover everything. So this is I
just want to comment, now that you pull it out, that exact picture there right now looks very much like what do you call it, like a cable, a conduit cable for not Ethernet, but the just a regular CAT cable they use for cable layouts and high-speed internet and that sort of thing, where you have an insulating layer, you have the conducting layer, and then you have things are wrapped around the outside with a conducting layer, and that all makes that inner wire able to conduct the signal without loss of the signal due to leaking through to the other layers and so on. So yeah, it's very interesting. What an amalgamation of different types of elements here. Okay, go ahead. Didn't mean to interrupt.
Nope, no problem. So this is just another prototype and another thought of mine. So it'll be stranded wire, insulated, in the core that I just showed you, and then it'll be this here is zinc, because there's poly, the poly, I don't know what you call it, but it's polyplastic, polypropylene plastic or whatever they call it. But it's you can nano coat this stuff. It shrinks and then it gets a little bit harder, and it holds shape. So I figure that it's good to go. So like I said,
That's a good point. It's kind of like shrink wrap, I guess, when you nano coat it with the coil inside like that, right?
Yes.
Yeah.
So then it'll hold, because each one of these, because you want to Gantz this, you don't want to Gantz that. So each time you insert, the Gantz will be inserted inside the plastic coating. So then the only part that doesn't get Gantzed is the actual stranded wire here, because how are you going to get that inside there? Nano coated, yes. Gantz, no. Gantz on the outside here, and then we go from there. So this is the only part that you're never ever going to get Gantz on the inside of that. I'm going to actually.
Maybe you could try some Gans water or something really thin. I just thought, what about this alcohol idea that's come up tonight? What if you had something really thin and thinner viscosity that would just sort of wick through really quickly?
Yes, wicking is everything with these stranded wires. That's why Lee uses them, because when you the wicking part of it, that's why you get the nano coating that happens so quickly, is because of the wicking. It's I don't know.
It allows some oxygen in between and the flow of the vapors and so on, whereas the solid wire doesn't allow that flow so easy. That's what I discovered, yeah.
So that's why I decided to go with the 12 gauge stranded wire in the middle, so that the wicking will get all of it through, and it's just as strong as, these are 14. I went 14 gauge here, solid. So I went up a little bit to the next step to help it, so that I knew that if I had power did go through this plasma power, it would be thick enough or heavy enough to take the surge. So then let's just move on. Yep. This is zinc that's covered, and then here we have the now I've moved into an aluminum tube. It's an actual aluminum tube. I think it's I think it's 7/16, and then you have the plastic coating, and that'll be nano coated. Then you have your exterior is your brass, and then you still have you have your plastic coating around that, and then to final out the is your copper. I found that here you do not want the brass deep within the core, because it becomes a insulator. And the reason why I learned that was I wasn't getting a reading, because the whole central pin I had the whole central pin here covered with the copper right up to the tip. And every time I tried to take a reading, I couldn't get anything. So I understood that out of reasonable deduction, I took some of it off, and it was still this was still nano coated underneath. And then once I did that, I started getting readings. So my determination is that the brass here is too much of an insulator so I thought, well, okay, That's, don't use that there. Bring it out to the very end as the very, to hold the whole package together. And then once the package is, charged, if it gets past this little bad boy, which is the brass, then we're in business. So we'll see. I made this. I'm gonna nano code everything, and we'll get some reading out of it. We'll see what happens. But at least I know. But out of all this stuff, I have to tip my hat to Armin, because the only difference between these two units, guess what? When I nano coded these things, Denny, I had the 7 or the 12 salts in the NOA when I did the heat process in this one. I did not have it in this one. This one was just nano coated as my regular way of nano coating things. But guess what? I learned, because this little guy was with my. I just happened to have it ready to go, and when I was making those other wires to start to make my connections, and I just said, well, I'll just throw this little guy in there because. And I nano coated this one, and it turned green like the other ones. And I messaged Armin, and I said to him, Armin, I used the 12 salts and everything in my nano coating, and everything turned green. And he said, well, Mark, you may have used a little bit too much in there. And I tried to explain to him, and he said, well, keep using it and see. Well, guess what? I kept using it, and this is the results of it. This has the 12 salts in it. This does not. And it was only on just the outside wires. Everything else was the same. Actually, everything else was completely the same. All the inner core, everything was made exactly the same, except for the outer core here had the 12 salts in the nano process.
I hear you, Mark. Thanks.
No, thank you, Denny.
Yeah, thanks, Mark. That was really good.
So that's all I got.
Well, keep an eye on that thing and see what are you gonna do with this now? Could you remind us what you're gonna use this for your power supply for your GANs collection, right?
Well, I just thought I'd throw it on one of my containers.
Yeah, well, have a look at it when you do that and see what the voltage is. Does it maintain a voltage and keep putting it into your containers? That would be interesting to see what that would be.
Well, like I said, it's just a fun little thing, and I have the I have everything written down that I used in my material on my plastic coatings to make, because what I make is I make a little solution with my powders, and then I just add a little bit of whatever if I'm using CO2 or CH3, or like when I made them, I make different ones here, you can see. But when you start mixing them, the thing you want to mix is that it becomes like a little bit of I could probably do it if you wanted to see, but what I do is I just make a little, I take the powder. This is my powder. These are my dried GANs powders, which consist of, and this is what I, through the years, I've wrote this down. This is a formula that was given to us through years, which consists of quartz crystals. Is my base, which is just a good pure sand, is quartz crystals. 5 ounces of quartz crystal sand. Seagrass, which is like seaweed or I actually use spirulina, which is an algae or that's been around for a long, long time. You can get it at a health food store. It's organic. I used a seashell, one whole seashell that weighed 5 grams. I used a pine cone, one pine cone from a blue spruce pine. Pine cones have been around for a long, long time, and spruce pines have been around for a long, long time. They hold a lot of different properties, and they're organic. And you might want to look into that. I used a whole root of a orchid. Okay, orchids have been on our earth for the stem of an orchid. You know, the base, which was the bulb of an orchid. Orchids have been is one of the first known plants on our planet, and I just thought that was just a beautiful thing to be part of this. Then moving on, I used raw cane sugar, unrefined cane sugar, half a cup of cane sugar. I used 5 grams of aluminum ground up. I used CO2, CH3, and CuO all in dried forms. How do you measure that? You know, I started out with, you know, in a liquid form, you know, an ounce for each one. But when you dry it out, how do you measure an ounce of pure GANs dried in a dried form? Your guess is as good as mine. All I did was take one of these little cups like this, filled it up to the top with just pure GANs, put it in one of these containers, and just let it dry out till it became a flake. I don't know how else to measure it. I don't know how else to do it, but I did it the same way for all 3 of them, and it went into here. Then what I did was I mixed all this stuff up with a coffee grinder, a bean grinder, and that's the consistency you get. It's just a pure powder, and that was what we were taught to. And then some people put dried caustic in it, but in my applications, I know where my dried caustic is going to be, because caustic pulls moisture into areas because it's pure lye and it wants to draw moisture in. So in my situations of my unit, I know there's going to be dry caustic in it. So I decided not to put caustic in it. Plus, I think caustic starts to make the if you had caustic and ground aluminum together, it would already start. You would already have activation in there, and you don't want that until you're ready to go. So I decided to be able to start my units or start my stuff when I wanted to. Once I added this, then we're in a go situation. So that's why I decided not to put dried caustics, dried lye, pure 100% lye in my dried.
Yeah, definitely have to watch out for the dry mixtures of powders, even in a closed container, because, for example, the copper oxide is the black stuff in a fine powder form is actually used in dynamite type explosives and so on. And same with aluminum. They're both can be essentially explosive.
Pardon me?
Oops, my internet was unstable there. I was talking about the powders being dangerous to work with sometimes because they can be explosive. Actually, copper oxide in a fine black powder form can be explosive, or it's added to explosives to add to the catalytic action basically, and in the best high-tech explosives as well. But the as far as that goes, sugar, what do they call it? The icing sugar is so fine that in a sugar refinery, they have a separate room for bagging the icing sugar because it's so explosive. So things, when they're in a very, very fine form, tend to ignite much easier than their grosser form. It's a whole different world in the nano world. Sorry, go ahead.
So that's just it. So with the sugar, though, what I found is it makes a hard coating on everything once it starts to dry out, and it makes a crystal coating. So I don't know if that helps. Crystals actually help to communicate or move information from one place to another. So I don't know how active the crystals are, the sugar.
Well, in that case, it could very well turn into a carbon-based coating as well. And we know with carbon-based critters, they tend to communicate through that CO2 carbon relationship and all that. So definitely.
So that's what I got going inside these. That's what's basically inside the coatings as I built these little cores. As I made it, they all got each one got a different layer, CH3 or CO2 or CuO. I layered it out, and I have it written down. We could go through it, but just so that you can get a different variation or a gradient. Thank you, Rick. Yeah, because you want to
that was Marco's big word that Mr. Keshe used to tease him about, because Mr. Keshe, I don't even know if he knew what gradient meant initially, and most people didn't probably, but Marco made it famous, and Mr. Keshe after that. So it's a good word. Yeah.
Yeah. So we want to try to make a different gradient or a different conditions. Everything is conditions. Everything I do, if you try to
Hello, Mark. I'm not sure if it's I think my internet's lagging. Yes, my connection is
more
dropping.
CO2. So however that works, everybody's going to have some conditions that'll be different from everybody else. Everybody's results will be different. But if we all keep collaborating and sharing our results with one another, then I think that's the way that we're going to achieve more.
So I get to break her in here when you're done.
I'm all done, but Denny, I don't know what else to say.
Well, I have a couple questions, but I also have some comments, and that I don't want to. I'm afraid that they might go too long, so I'm going to try to keep them short. Number one is the amino acids, a process to make a lot of amino acids, it being more important than the GANs for a specific use I want. I know that Francois, who was a student, I think a first year student from the lessons, had a system that he was trying to make a certain amount of GANs, but he came up with a lot of the amino acids. And I said, well, that's what you want. And you keep that, you want to remember that system, so that because at some time you may want to have a lot of amino acids. Now, the reason why I would want a lot of amino acids is that I want to use it for fat. When I make my GANs and my GANs coating, I want a lot of fat around it. Otherwise, I could use vegetable fat, or I could use animal fat, but I keep thinking ahead in the way, well, if I'm not going to be killing any plants, and if I'm not going to be killing any animals, I better learn how to make my fat. And the reason why I want to have the fat and mix my GANs with the fat, and then I have another little statement before I answer that question for myself, is that do I need to take all the salt and wash my GANSs and get all the salt out? If I put my if I put my mineral salts in, and I put the covering where I don't, and so then I can make things really thin layers and have the fat be the insulation, and have the salts and the sugars be the negative and positive flows. And so then I can make sheets of to make a battery and get a more efficient battery, and one that can take a longer time to release all its energies. And I'm looking at that. Well, if I'm wanting an off-grid system, I want to have a real strong battery capacitor, and if I don't, I want to make it large enough so it does the purpose. So if I can use the fat as the insulator and emulsifier, so that the salts and the sugars don't dissipate. And if I use amino acids that I'm making off of my kit, then that is what I would be shooting for. So the next thing that I have to figure out is how to make a CO2 kit that produces a lot of amino acids. In other words, I call that fat. And then to be able to collect the fat, so when I mix my GANSs together, I don't really have a powder. I have my GANSs emulsified in the fat. That's the comment that I want to make. I did have one other comment that I wanted to make when everybody was talking about the nano-coating processes of copper. There's a system, if you nano-coat the zinc, it pits the zinc, and you put graphene oxide, I guess they call it GO, and you put that over the zinc, and you let it sit there for a while. You've basically you're actually wanting the pit, so because that's why you're nano-coating it with NaOH, and then you let it sit there for a while. Then you take your sticky tape and you stick it on that, and you peel it off. There you have your graphene, the oxygen, and the So that's some comments that I just wanted to drop in here about. And if somebody knows how to make the amino acids and on a production scale where that's what they're after, I would like to know it. That's it. Thanks. Anybody got any tips on how to set up a kit where you're getting a good production of the?
If you look at the movie Frankenstein, commonly known as Frankenstein, you might get some clues on how to pick up a bunch of GANs in a hurry. But that's a different subject. Well, it's a good point. What is the best production? I mean, for example, I think some of the GANs that people are picking up on the CO2 kits and off the zinc plate and so on is probably from the acids and oils on our skin, on our fingers, when we handle the plates and are touching things, end up being liberated on the surface of the liquid when it's in that process.
I understand that different ganses make a different amino acid as well. At least that's what I thought I heard Mr. Keshe say.
And what about the Mark's technique, which seems like the perfect way to pick up that connection with your body, where you soak your feet in the salt water?
When
what's
Mark
more
said
perfect?
he has different, he will have different environment for his equipment. I said to myself, well, I'm not soaking my feet, so there's going to be a big difference there.
Well, people running around scraping off the bathtub ring, for GANs and for amino acids. It's not so funny in a way, because that would be full of our DNA.
Yeah, but I'm after the purest. I just want the GANs from my kits, whether it's CO2, whether it's copper oxide, whether it's the hemoglobin amino acids or the CH3 amino acids. That's what I want, but I want to have enough of them. So that when I emulsify my GANs in there, I got mostly fats, and that's my outside covering. That's my insulator, rather than an electrolyte. It could also be the electrolyte, but so that's the concept in my mind, and I just. If I use the amino acids, then it's a connection anybody can use. That's my thought. So anybody wants to, Mark, I hope I didn't. I had that comment, but I also wanted to let you know that might be a way also to make batteries where you can eliminate. And I don't think you want to, because it's working here for you. Eliminate the tubing, because that way, if you eliminate the tubing, then you can get you're basically miniaturizing things. And I also was thinking of Thomas as the way he's trying to connect things, and even making his nano coating act as a capacitor just with nano coating. And that's an interesting thought as well. Well, thank you guys for the time. That means this end is out. That means over and out.
Thank you, Denny. Just had to get my headphones off the floor here. Fell down. There we go. All right. Back to you, Mark. You got anything else there you'd like to say? What would you like to do now?
Oh, that's it for me. I don't have much else. I'm just going to keep on working away here. And like I said, I'm going to try to put that on one of my containers. I'm going to actually use this one for the container that Armin told me to, the big hodgepodge of GANs. Because he wanted me to have a closed, looped container with everything nano-coated and the 12 salts. So, on my end, I always use my N number 6 position over here in my GANs. Last time I used the rocks and everything. I have another idea for the rocks this time too, but this time I'm going to try all the plates, like you said. I'm going to try to. The only thing I can't find that nobody can tell me for sure is the magnesium. the diode that is in a hot water tank that we
The
thought maybe it was
anode. Uh-huh.
an anode. And I went to I just went to my local scrap place, and they said, "Well, I don't know if it's a complete man. How are you gonna tell?" And I said, "Well, I don't know." I
Well,
said,
that's exactly. That's what they would probably. That's exactly what they would say, and in that accent too, probably. But while it is a bit of an issue, yeah, you should. I mean, to be completely.
I'm just glad they didn't sick the junkyard dog on me.
Yeah. So, yeah, I'd be better off to order something from the internet. Likely, it's getting harder to get the pure magnesium anything. It's hard to get pure anything these days.
All right. Yeah, because they looked at me like, "Hey, buddy, put your tin hat on. Go on about your business." So.
Yeah, you might. It's hard to know what you might be doing with magnesium.
So anyway, yeah, until I can find that, that's going to be in my number 6 position, and I'm cleaning up the rocks. I bought a couple other rocks that I'm gonna try an all rock GANs.
I think that's a really elegant idea. I mean, geez, what if you crash land here a million years ago as a space astronaut, and you look around and, oh geez, there's no factories for making stuff here. What kind of primitive planet is this? Oh, rocks. Okay, well, we put a couple of rocks together and try to make some nanomaterials and make some GANs, and from the nanomaterials you can make the pure elements, and then you can create new materials and create this and create that, and all of a sudden you've got your spaceship there, and you get the heck off of planet Earth, and we didn't even know about it. So the smart space astronauts, they didn't leave any trace, and they left a long time ago. So we got to be careful who we're dealing with, probably. Okay. Anything else there, Mark? We should probably wind things up here quite soon,
Yep.
folks, because my internet keeps kicking out,
That's it for me.
having trouble here.
Well, I can't let you do that, Rick.
Oh, thank you, Danny.
I'm trying to get an update on Thomas's health unit and a few other things that he was doing. I wonder if he's still around and
Yeah, and by the way, Zoltan had a question. He said, Mark, do you want to measure the capacitance from your capacitors?
Yes.
There's no capacitance measurement on your meter?
How would I do that?
Well, some meters have capacitance. Mine has a capacitance setting, but I had to pay extra for the meter to get the capacitance setting. The cheaper ones don't usually have that. Okay, so yeah, that's it. Keep it steady and try to zero in. Yeah. Let's see. We've got voltage. There's voltage on the left and right of the off. It looks like so to be direct and alternating current there. And we said there's an ohm setting, which is what, on the bottom left?
Yes, down here.
Yeah, and what about on the other side, opposite that? Up there.
Well, there's this is all amps up here.
Okay. Right,
And
right.
then this is all volts up here.
Yeah. And at the bottom, at the bottom right, at the 5 o'clock position. Yeah. What's that?
Just for a battery, it's 1.5
Okay.
volts or 9 volts.
Good. Yeah, you don't have the capacity settings on your meter, so you would have to do it another way. So one of the ways that people are measuring capacity of their plasma capacitors now is you take a known capacitor and put that in line with your plasma capacitor, and since you know the capacity of the one known capacitor, then you can add on the capacity of the other one, and see what the see what the reading is. So some people are doing
resistor
that.
or a capacitor?
Well, that would be a resistor there, yes.
So would I put that on, or would I put a?
Well, you would have to have a capacity meter to measure the capacitance of your capacitor. It's a different setting than the voltage and the amperage and the.
So if I bought a meter that, you know, do they make a handheld meter like that?
Yeah, definitely.
Okay.
That's what I have.
Okay.
But I
And
had
how
to
much
pay. I had to pay. I think it was $60 or $70.
Oh, that's nothing. That's
To
okay.
get one with capacity.
Okay. What would I look for? Does it say capacity?
Yeah, it'll be like what they call a volt ohm meter normally, but it'll be volt ohm and capacitance, for example. It'll just have an extra scale for capacitance. Sorry, I'm really lagged out here. My connection is dropping.
Yep. We're losing, yeah. Must be an omen to wrap things up.
I think so.
Oh, you can't quit yet.
They're getting
Just
weak.
because
You
just
can
because you're
barely hear me. I'm fading away.
yeah, we can hear you quite well. You can't
You can
pull
hear
the
me faking it, is what it is. Yeah. Okay, go ahead, Denny. Drag me through the night here.
well, first of all, I don't know if Lee got his full chance to say his stuff, and I'm interested in Thomas's health unit to see if he's
Yeah, I see
Okay,
here.
take her away, boys. If I
Um,
crash out, well, so be it.
oops, should be fine. Should be
Uh,
okay. The health
I mean,
units.
it'd be good to have some sort of picture though while we're up here. I can put on my video, but I'm probably better off to have somebody else put a picture or video or share screen or just something. Otherwise, it's a black in the Zoom and it doesn't look good in the
Right, I will
recording.
try share some
Perfect.
health unit elements from the health units, because still in progress. I still got some stuff to do. I'm still not ready. And now we actually with the friends do the test from this, let's say, operator inside the system.
we
So
can't see your picture.
okay, wait a moment, and actually.
I could share a screen just to share a screen if you want, but if you got the health picture, that'd be good.
I show you guys something. This is very early stage. Yeah, that's a very early stage for capacitors and batteries for the health unit. Oh, wait a moment. I need to manage. All right, because I was creating something like a one line, and everything is in a one line. So less copper, less everything. The construction is self-stabilizing. So it's really good. That's a different capacitor. So that's only one thing when I got to show for now for the health unit. I mean, still is in progress. The big one, I still got some stuff to do, and probably the next week I will get something to show, but I'm not sure yet because I don't know. I don't know how long gonna take to finalize all this stuff because a few things, even the nano coating, I was basically clean up one of my big steaming pot and take the gases out and actually need rebuild once again the reactor inside. So that's gonna be actually a quick job, but it's like a next 2 days, something like that. So it's gonna take extra time. So I will please some a little bit more patient with the health units, and soon I will show you guys something more about this unit and few. I think a little bit different solution maybe gonna be helpful for someone who actually try go this way. I mean, to build the big unit. So it's few very interesting things. For example, for now, one of the most astonishing actually things that's the operator inside the unit. So when you stay behind behind the wall with batteries in the capacitor, especially with these black mirrors, and you start pumping up the field, something like, I don't know, do kind of rotation around the coils, behind the coils and the capacitors, do some kind of movement direct to the person inside the system. The effect is basically astonishing. I got a gentleman inside the system because half of the system is done, but this is not only half of the system. It was a really funny situation. The gentleman sitting on a chair, and he just stuck in this chair in a very strange way. I asked him what's happened, and his answer was, he started feel some like like a movement on the ocean, like he's on the ship, and it's really strong wave, and he got kind of feeling fall down for this chair. It was really funny because the chair is quite big, quite solid. It's physically impossible just fall down for this chair, but the gentleman got the strange feeling. So that's what's happened when you operate behind the system and someone is inside the system. So, and we now just checking a few different ways how to operate with the person inside the system, how to amplify the effects, maybe point the effect to some specific areas or something like that. So it's really kind of big thing, I think, for now, for my friends and for me to do with this big health units. Quite really inspirating. So let's see what's gonna happen next. Now we know for sure the miracle happened behind the wall with the capacitors and the coils, not behind the wall with only coils. So the receiving wall is actually the main place to be an operator for the sort of system. So this is one of the latest discoveries, and we just try and find some kind of sort of unification for this movement behind the behind the system. And what you should do, basically, you should actually do something like a rotation movement with mirrors or with your hands behind the coils with the capacitors, or just pump it up, just push and back again, push and back again. So, and we're just checking which way is more effective, or actually, or maybe everything is effective in this same way. We need to check these things now. So that's the progress what we got here with this big systems. So the more things will be in the next week, and more other things because there's more other things, but everything is in under construction condition.
So do you got any other secrets you're working on?
Always.
So I was
now seriously, guys. Then now I really recommend to you guys try with the ethanol alcohol, even on the last stage. Maybe not across all the nano coating, because my mates from Germany, they do photography from the microscope when they done this nano coating by alcohol the first time. So they got access to quite really expensive professional microscope. I don't know how big, how small. This kind of microscope for I don't know 100,000 euro. It's quite expensive stuff, laboratory stuff, and they spot some gaps inside this nano coating, but they done only with the alcohol and caustic soda. So, and they find the small gaps. So I was decided stay with the caustic soda and cover up completely every nano-coated elements. And on the last stage, to avoid every single problems with this kind of dots, the nano-coated places, I was decided to stay with the caustic soda and apply alcohol only on the last stage, not that much, just only, I don't know, maybe by 3 liters, maybe by 2 liters was like 200 milliliters of alcohol maximum. That's all. They helped me actually keep the very strong vapor condition, and also I was just checking now the gases from the pod, because I was cleaning up everything and separate the gases and from the liquids, and does look like I got quite interesting guns inside. So after all these operations, so I mean, if you got some ethanol alcohol, any type of alcohol, just check by yourself. I think it's pretty good fun, and the coils look amazing. And this mesh layer is quite. Oh, sorry, that's my electric meter. This is the most important layer for electricity for the Magraph system. Is just massive. And I was done the test on the brass because the one of the secret plans I got this Tibetan bowl, and it's half nano coated already. It's not ready yet in final, but half is done. And I was check this nano coating made by alcohol. That's this brass bowl. And the nano coat this nano coating is so tough, is so hard, is so solid. I was really surprised. Basically, it's something a little bit different.
So this bowl, that's like one of those sound. Yeah.
I mean, the sound is still.
I'll have to kick Rick off here so I can see your bowl.
Give me 1 week because it's ready yet. It's only in a half nano coated, so the sound is not finally turned to these crystal ones, and I need to actually spend some extra time with this bowl. So
this is a brass bowl, right?
Yeah, exactly.
What size is it?
6-7 inch, something like that.
Okay.
The small ones, nothing big. So I was check this idea with the alcohol, and the nano coated layer is just amazing. It's so tough, and I never see before something like that. And also on the coils, I got this fantastic kind of bluish violet mesh. So which is really
you have
good.
To show us a picture, otherwise
it's gonna be.
Otherwise, you're teasing.
Exactly. The next week, I wait for the.
But we got to have some kind of picture up here on the screen because Zoom just puts a big funny mark on this.
I'll put my my animation back up here.
Yeah. So
unfortunately, I didn't get any photography from the coils. I'm just looking for something, but I don't think so. Maybe something. Maybe. No any photography. So next week I will be more prepared, and I show you guys how look all these layers. So that was my research in this week, and also I was made a lot of soap with the CO2 and zinc oxide, and was really good fun.
Rick is having a tough time controlling his spaceship. He has missed Alpha Centauri twice, and so
flying to different directions, different galactics.
And so
speaking about some nano coating, and Rick is already on the Mars.
So I have to ask you another question. You and your friends know how to make a lot of amino acid on top of your kits?
Depends. Some people yes, some people no. I mean, I think this is fluctuation. This is not the constant process. Sometimes I've got a lot of amino acids, sometimes by a few months, and sometimes, for example, for now, they be stopped. It's not that's like before. That's many like before. I mean, and other different the difference between the different gases, because for example, if the amino acids on top of the CO2 stops, the amino acids top of the, for example, copper gas, they started. It's like something go to slow down, something going to speed up, and it's not an absolutely constant situation. It's always
I want it at least 60 millimeters thick. I mean, I want it thick like the cream on the top of the milk of the Jersey cow.
You lucky one.
that's
I got
what,
a small drop of amino acids. Unfortunately, I've got a fantastic collection of amino acids, but unfortunately, when I clean up the box, I was lost everything, as probably happened to everyone a few times, with some fantastic collection of amino acids. But so anyway, I still got some few amino acids, not as much like you, but maybe next week's the CO2 will start again, so I will collect some extra amino acids. So let's see what's gonna happen next. Now I get a bunch of amino acids from copper. I was surprised how much. So, but that's the copper story. So that's I think I show you guys one thing through the ends by pictures. Give me a second. I will show you a lot of fun with soap. If you like to do soap with the CO2, with all the stuff, they already done. That was CO2 and zinc oxide. That was on the bottom. That was CO2, zinc oxide, and CH3. Kind of refreshing. Oops. Everything made on plasma. I was put the stamp top of the soap. That's the other ones. Different gases. I mean, different combination of gases. That was mostly zinc oxide and CO2 with bigger proportion with the zinc oxide and a little bit copper gas. So that's from the closer view. Fantastic texture. Fantastic smell. That was the orange. We was decided to go for the orange and natural ingredients like
what oils did you use? Yeah, like coconut oil.
Coconut oil, castor oil, oil of oil, almonds oil, a little bit palm oil, few different oils. It was like I don't know 5-7 different types of oils. I was collecting this oil especially through the soaps to actually make something like a good combination. I will spend some few days on Google just checking how people do these things because I was done only once before and that was the second time. And the different composition, that was the extra because I was apply extra ganses. Not always we get the basic ganses. I get some, for example, gans from cannabis. So one of those that was the fresh ones. That was with the gases from cannabis. This both. Also to CO2 and zinc oxide, and I mean, I just do a few different types. One type is with the copper, not gas, with the liquid plasma, because everywhere is actually liquid plasma, not physical gas. So that was the copper liquid plasma and zinc oxide, kind of happy set. That was the CO2 and the natural gases like pollen, for example. That was one of the things. Bring the color. The also with the oils, the one trick is beeswax. Beeswax gets a good melting point and also is a gas state substance. So it's kind of very welcome as the big chunk of soaps before cutting. And also I was applying another GANS state substance, very healthy for human body. I'm just looking there. What's the name? Propolis. Propolis. Exactly. That was the propolis. The soap with the propolis. The black chunks. That's a piece of propolis, because this is the GANS state 2. It is a very gansy soaps. That's all the collection. That's what I made with my mate in one afternoon, actually, one evening in the afternoon, something like that. It was a lot of fun, a lot of caustic soda, a lot of oil. So now we wait for the next month and a half, because all the soaps are made in a natural, organic way. They need grow-ups like a cheese for the next month and a half, something like that. So that was fun from the last weekend. Yeah. And that's the most good-looking soaps for all this collection, I think. Looks a little bit like a marble. That was CO2, zinc oxide, and CH3. And the second one is like a combination. The one soap is to make you active, to make you energetic. The second one is with the CO. That's mean the copper liquid plasma. So the all the skin infections, something like that, sort of thing. So that was the idea. And also this both combine the GANs liquid plasma from cannabis. If you get some skin problems, it's one of the best thing to use the best plants, the best medicine. So this kind of things. So yeah, that's all, I think. Oh, that was the orange. That was the orange. Unfortunately, we got some small problem, but finally we managed to actually go to happy end with the soap, and the smell fantastic from the real orange. Not any oil with the smell made in some synthetic way, or everything full organic. So that was the fun.
It looks good enough to eat.
Exactly. But please,
maybe it'll have new meaning to cleaning your mouth out with soap. Now it would be an enjoyable experience to swear and have your mother do that, if your mother
that's
ever
the texture,
did that.
guys. That's the texture. That's how they look. Look actually pretty much fantastic. It's a little bit transparent, something like that.
Mm-hmm.
Like a gel, but it's no any glycerin, no any artificial substances, nothing like that. Just only ganses, liquid plasma from the ganses, different combination. I was trying different varieties. I mean, different proportions also too, because sometimes you got the 2 of 3. This is the CO2, and 1 of 3. This is the zinc oxide with some other proportions from different ganses. So you're actually always able to manage the area what you like to point at. So it's gonna be more like relaxing your nerve system when you take a bath, or gonna be something more relax your muscles, or both together, or something like that. So that was the idea behind. That's a nice texture. The small black chunks, that's the propolis. The smell is amazing. Even if it's fresh and everything stinks like a caustic soda, those one smell like I don't know, like something from bees, from honey bee, something like that. So that was the next one.
And how long do you let it sit to let the caustic out and so on?
1 month and half, something like
month
that.
And a half.
2 months is kind of maximum. Is absolutely fine.
Mm-hmm. Okay.
And that's how they look together. Oh, I got shot. That's a nano coating made by alcohol. Sorry, I got it one. See, that's the copper ring, and top of the copper ring you get this nano coated layer made by alcohol. A kind of bluish color. You didn't see on the photography because it's really difficult to catch this kind of reflections when you do photography, but it's pretty much something like that. I mean, I was smashed a little bit by gloves. That's the scratches. I was touched them, unfortunately. But all these things, kind of bluish, violet reflections. That's the alcohol inside your solution on in the last moment, something like that. If you like to do on cold, I think is quite interesting thing to check what's gonna happen. So that's enough for today, Rick.
Okay, thank you very much, Thomas. That's always great stuff.
Yes,
thanks for the clear pictures too. That makes a big difference to have those nice close-up clear shots there of the soap and whatnot.
Thank you for the opportunity to share all these things, and sorry for floating everyone with this logo on the soap, but we got a lot of fun with actually how to do the stamp on the fresh soap, and finally we just figured it out. So a lot of
All
fun
right.
for big boys. I mean, if you someone like to do the soap, really guys, good fun. You don't need to spend all the day. If you will prepare yourself, reading some introduction on internet, all the action take maybe 1 hour, and you get fantastic collection, whole homemade, really luxury soaps. So with the
Okay.
plasma.
Well, we'll see. We'll save the secrets of soap for our next session.
All right.
Well,
Thank you.
I have another question,
Of course you do, Denny.
and but I guess Lee he didn't show stuff already, did he? And but I have a
Well, he
question.
did. Yes, he did indeed. Where were
Okay,
you then? Were
oh
you
yeah,
late, Denny?
yeah, yeah,
Denny come lately, and now you want to keep us all late. Oh, that's
yeah.
very
Well,
clever.
I had a chore to
Did
do.
you have a snooze, too? Did you
No,
get to
I had a
sleep
chore
before
to
the
do.
session?
No, Christopher pooped his pants.
Oh yeah, sorry, I don't even want to go there. You have more obligations than I can even conceive of. So
Well, I
I
got
can
it.
never put you in that kind of position. That's for
And
sure.
so, uh,
Okay.
looking at Mark's ability to nano coat those that capacitor battery that he made, then I'm really looking forward to him nano coating the coils, a stacker unit, or into a form of a health stacker, and because he will be using the plasma fields that every part of the body would be using and needing. You might never have to eat if you're in that environment, and you may never even have to wash.
Even more importantly.
So yeah, Mark,
Wow.
Thank you so
Well,
much.
hey,
That's what
I
I'm
need to
hoping.
work
Denny,
out.
Denny, imagine if you're in your position and taking care of your grandkid, and the grandkid didn't have to eat, and therefore didn't have to poop.
I've been
Wouldn't
thinking
that be a beautiful situation?
I've been thinking about that, but then this thing about losing your stomach and every part of your body, you don't need these parts anymore. I
Yeah,
don't
and
know
when
if
you're a kid trying to grow those parts, it's probably a bit counter-indicative,
yeah,
counter.
I don't know if I want to give up those things yet. So
Yeah.
I just might. Well, Mark, I'm looking forward to
You
your
might
next.
not want to give up those, but Christopher might.
Yeah,
Yeah, that's the thing.
Christopher, he loves everybody. It's he's just a loving soul. But
We love him too.
I
so
think
I'm
hanging out with you for long periods of time probably helped in that situation too.
yeah, he's
Anyway,
fun. Okay, I don't have anything more to add. I'm just I'm trying to get more knowledge from everybody here and some secrets from everybody before I have to do some more work. I have some time constraints, and but I'm interested in the battery side, going from the plasma into the what is that matter state, so that because I want to run the okay, I want to run
well, yeah, that's
the
where the
electrical supply.
electrons. That's right. It's where the electrons are. It's where all the action is here on the matter level conditions.
Yeah, well,
So
I have to
you're
run.
right. That's where Keshe was talking about in the last workshop, the
You have to
interaction
run motors. You
between the
have to run
plasma.
motors.
Right.
Christopher's,
Well, this
that's
is what
Christopher's got me.
we need to work on more animations and try to animate that process of the different levels and how it goes back down from the GANs to the plasma and to the nano and into the matter level to move the electrons, and how we can have electrons that conversely work the other way to move the plasma and so on, and that we can work with that. Be good to have some animations. I was thinking even like sort of a little game where you have your copper wire and you have to select things in order to nano coat the wire, and then you nano coat it, and then you select things to create the environment of the wire plus zinc plate and in salt water, and then boom, you create this new material, this GANS material, and then you get to use that and create things with that material. And like everything starts out with just fields to begin with your little play area kit game thing. I'm sort of making this up as I go along, starting to make sense here now. It could be fun. I'm inspired because the other day I saw there's this game they're showing on the plasma, or sorry, some of the physics news releases where there's a 5-year-old is learning nuclear physics from playing a game, and the game is very simple, and you try to hit the central heavy atom with your electron or proton or something, your heavy particle. And when you hit it, it splits off, and you learn how to add these up and all this stuff right in the game. And it said within an hour, this 5-year-old knew more than most nuclear physicists about the actual process and how one particle could break off into other ones, and the fission and fusion things going on and so on. So I thought, wow, we should be able to do that with this plasma technology, with the stuff that's been presented to us and things we've learned, to not dumb it down, that's the wrong word, but to make it simplify, get the very essential basics of what it is that we're trying to show, such that even a 5-year-old can go binga banga bonga banga, oh, I know what nanomaterials are, and I know what nano layers are, because I built them in this little game, or I experienced it in this situation. So let's think about that and try to play with that a bit. I know there's people out there that have that sort of in the back of their mind and trying to bring it to the foremind a little more. So anybody else have something they'd like to say before I wrap things up here? Because I'd like to call it quits. My internet is kicking in and out quite regularly. I'd like to know what's going on there. So hello?
Yes, here is Martin. Hi.
Hi, Martin.
Just to Danny, and first, in the beginning, you talked about the batteries. The problem by the car batteries is when they are in work, they create a lot of hydrogen, and the hydrogen produces then, as a copies, then the electrolyte, exactly the electrolyte, what's in there, and that goes down, like GANS goes down and settles there. And when it reaches the level of the plates, then you have the shortages. Then you have then the battery is old. The battery is not old, but you have produced exact the material that is inside the battery, so it is a perfect copy machine. So what is missing there is the outlet, so that you can quasi earn the material back to the. And for me, this is also a way to go, if you have energy, or if you have hydrogen, just by solar, or just by every night, when you create hydrogen by slow current, and then you have this copy machine in action. So And so you can earn the complexes, the liquid substances, fats and alcohol, whatever, you copy that. And this then you can collect. And when you collect it, you become more. This is a problem by the batteries, but is good to know because.
Can I jump on a second, Martin?
Yes.
I've got one observation because I do some experiment with 2 old batteries, 12-year-old, and they officially should be completely dead. And I recharged them once again, and they work in condition now. Not the perfect condition, but I think I was bring something like maybe 50, maybe 70% back. But they was completely dead, like a disco music. Anyway. The point with this battery, because I was trying a few different ways. On the start was really tough, and I didn't achieve any results because combination of gases was not right. And someday I was just spot the description on the batteries like a PB battery, and just stay looking this description like a PB. Tom, you are so idiot. You just forgot the most important guns, the lead guns. This is the main ingredient inside this battery. So, and when I was applied this extra guns, the lead guns, through the system, I got some like a small system made by basically few capacitors and some mini magraphs, stuff like that. Nothing fancy, nothing big, just only temporary kind of solution to recharge this battery, or trying to recharge this battery. So after when I was apply this specific guns, all this process starts immediately. So, and I was boiling with these batteries for 5 months, and without no any special result. I was charged them, but maybe on a 10, maybe 1.5%, something like that. Really small amount of power. That was more than joke than charging process. So, but after when I, as you say, go for the solution, I just use same material, I mean same fields, but in the gun state on the opposite side, inside the capacitors, inside the system, the batteries start talk to me. So that was my observation, and that's what I normally do when I create something like a combination of gases through the car magraphs. I try to use the gases from materials who actually exist inside the engine. That's the very important thing, to catch the fields, because the one thing when I get the fields, I operate with the fields. So if I get the fields from the right materials, so I get the grip with the right materials. So I'm the master, and I control the environment from this material. So that's the point. So that's that's how I manage to actually figure out with these things. That's the way how I try connect all these gases and the materials and the functionality. So, thank you.
Thank you, Thomas.
Thank you.
Okay, I'm going to cut things off there, and I'm going to end the meeting today with a video from Pia, who's here actually in the meeting today, and she's donated a nice song and video, and I'll tack it on to the end here as an extra treat, and I think it's 4 minutes or something. And let me introduce that now. So it's from Pia Larson of Rain Beat Music. It's called Inspiration. Or sorry, it's called Invitation, not Inspiration. Invitation to Peace would be the full name, I suppose you might say. Alright, let me get rid of my video, get this set up.
Farewell to wars. Now it's time peace forever. We salute you, friends. We welcome you. Peace forever. Oh yeah, peace forever. So many years we've been waiting for you. Too many times they're shot at you. When you come with peace, oh yeah. One time, two times, now all times we face the day. You land your ships with peace. Oh yeah. We miss you. We invite you to land. Welcome you with peace. To arrive on a coast, truth to release. No more doubt, no more fear in our hearts. We open the box, my friend, to brand new start. We invite you to land. Welcome you with peace. To arrive on a coast, the truth to release. No more doubt, no more fear in our hearts. We've opened the box, my friend, to brand new start. We salute you, friends. It's time for your arrival. Farewell to wars, goodbye to destruction. Don't need it anymore. Oh yeah. I'm ready. One time, two times, now all times we'll face the day. You land your ships with peace. Oh yeah, yeah, we'll meet you. We invite you to land. Welcome you in peace. To arrive on the coast, the truth to release. No more doubt, no more fear in our hearts. We've opened the box, my friend, to brand new start. Invite you to land. Invite you with to arrive on the coast. Invite you here with peace. No more doubt, no more fear in our hearts. We invite you box, my friend, to brand new start. Farewell to wars. Now it's time for your arrival. Now get on board with peace forever. Peace forever. Yeah, yeah, yeah. We salute you, friends. We welcome you. Peace forever. It's time for your arrival. Peace forever. Yeah. We invite you to land. Welcome you with peace. To arrive on the coast, truth to release. No more doubt, no more fear in our hearts. We've opened the box, my friend, to brand new start. Invite you to land. Invite you with to arrive on the coast. Invite you here with peace. No more doubt, no more fear in our hearts. We invite you box, my to a brand new start. We invite you with to arrive on the coast. We welcome you to arrive on the coast. Invite you, invite you, start. Invite you to land. Invite you with peace to arrive on the coast. The truth to release. No more doubt, no more fear in our hearts. We open the box, my friend, to brand new start.
Pretty good, eh?
Thought you might like that. That's from Pia Larson, and that's a very nicely put together video and music all done by her. So I thought that's pretty impressive, and I hope they use that at the Rome event as well and play it there. I think it'd be appropriate. All right, thank you everybody for attending here today. Let me, I've got my video. I should throw my, where is it? Here it is. Put it on before we end here. And just say, yes, hi everybody, bye everybody, and thank you for being here. Thanks for all the participation and questions and comments and so on. That's what keeps it all going here. And
nice music too.
And good music. Hey, that's a bonus. It'd be nice to have a theme song. That's a pretty good one, actually. Hi, Doug. Thanks for waving and your comments, everlasting comments. All right, I'm going to end the live stream here now.